Today we're going into Biomimetic Footwear V2. Very excited. Last one was a lot of fun. Really excited for this one. So I'll introduce you. Shun, do you prefer to be called Shun or Ping?
Ping? Maybe Ping is good.
Ping? Okay. Because I can never tell because all of your social media in a different order. Like sometimes Ping, Shun, sometimes Shun.
Right, I get it's a little bit confusing sometimes, but most of the time, I think my friends call me Ping, so I think it's easy to remember as well. So yeah.
So what is it, like Ping Shun?
Actually, it's Pek Shun Ping because it's like
yeah, gotcha.
Like in Asia, like our first family name comes first. But I kind of did it like so
cool.
It's all good.
Well, welcome. Ping is based in Tokyo, Japan, originally from Singapore, and graduated with a degree in product design. He has 6 years of experience working in branding and packaging with clients like Procter & Gamble, Macallan, and Adidas. His true passion is in footwear design, which leads him to join competitions held by Pencil, actively posting works on social media and working with footwear brands before starting his brand. And you're also the founder of Aliveform. So welcome, Ping. We're very happy to have you here. Let me stop sharing here. And right before you go, just before you start, just to everyone here attending, please, if you have questions during the webinar, please use the Q&A button. So if you look where all your buttons are on the bottom or wherever all your buttons are for Zoom, there's one called Q&A. It's like 2 bubbles. That's where you should ask questions pertaining to the webinar. Best to stay relevant to what's going on in the webinar. Other than that, you can chat along in the chat, but make sure to switch your chat to say everyone instead of host and panelists. So, and just a reminder that not everyone learns at the same pace. And so we try to teach as much as we can. If you feel you can't keep up, just remember that there is a recording. So yeah, thank you.
Cool. Thanks, thanks Michael for like the introduction. Yeah. Excited to like start this class. So yeah, I think it's all good. Then maybe I can like start the webinar. So welcome everyone to Biomimetic Footwear 2.0. So like we had quite a lot of fun. For the first one, we're like trying to, so we were inspired by design from nature and just like how in terms of like, for example, like patterns or structures that you see in nature or looks similar to nature being like less predictive and more organic. And that's kind of like what I'm also interested in, like, and also focusing into footwear, right? So like taking a combination of both. So like I just do like sort of like a overall kind of overarching content, like our topics that we're gonna cover today. So for today, we're gonna do a couple of stuff. So first, I was just like I kind of wanted to look at like design a more like overarching views in terms of like my workflow, and then kind of get into like the design portion. So I think recently like using AI is quite helpful. So I think I'm just gonna do like quite a short like session of AI to kind of warm things up, and maybe we could like get some prompts together and maybe try getting a few designs out. Then after that, like I already have a design that that's ready. I send you guys the files. I hope you already received them, and kind of like maybe just check them out a little bit before we actually get into that. So with that, we'll be looking to create a kind of recreate the design from one of my actual shoes. it's called Armis. So it's the low version. There's a couple like a variation of them, but it's the low version that we're gonna be working on. So with that, we'll be using Rhino and Grasshopper. So with Grasshopper, you would need these few plugins. So if you have not got them yet, maybe you could like quickly download them while we're still like talking about MidJourney. Like, so we need like Pufferfish, Parakeet, Weaverbird. I can type in the chat. Pufferfish, Parakeet, Weaverbird, Crystallon, Lunchbox, Intralattice, MeshEdit, and Dendro. So let me just type it real quick inside. So, you know, just to be sure. And then after that, we will we'll kind of also kind of work a little bit in KeyShot, just like in terms of presentation. So something just like something simple. That's kind of like also like the workflow that I usually get into, like trying to get a concept out. So really ideally, like sort of like if you can get a like a MidJourney to kind of start your like concept and idea, and kind of like evolving that into your actual design workflow and doing the actual 3D. Then lastly, trying to, you know, create a, I guess like convincing render, you know, to kind of present your ideas. I think that's usually what I find helpful if I were to imagine myself take a course. So I thought like maybe I could like, you know, have this. So, okay, so in that case, maybe I can start soon. But before I start, I just wanted to check out with you guys if does any one of you not have experience with Rhino or Grasshopper before?
You can raise, they can use the raise hand.
Yeah, if you don't.
If you have 0 experience, you can raise your hand.
Okay. Seems like everyone is cool. So far, I think everyone has to have some experience with that. How about the okay, beginner? Yeah, that's fine. Beginner, that's fine. So I'll just like do like a quick, like I think like introduction to like maybe sub D and oh, okay. So I think we've got people that are like really good into that, really familiar with that as well. How about MidJourney? Like, did you guys already had, or anyone, I think it's easier to ask it the other way around. Anyone that doesn't have any experience with like some sort of like AI, like image generation prompt kind of thing at all? Yeah, DALL-E is good too. Like just like understanding kind of like how it works would be helpful, and then I kind of it's easier to, you know, get into like the context of what we're doing. No experience. Okay, yeah, that's fine. I think like with like AI, it's fairly simple as well. So I could just like explain real quick. I think that's quite straightforward, and then you can take a look at that, like kind of look more into that like when you have time. But I think like overall like introduction of that would be good. Then I think that should be yeah, more or less. And yeah, so without further ado, maybe we could start with MidJourney, I guess. So
No, let's go for it.
yeah, like yeah. So I think the reason why I wanted to kind of start with MidJourney is that I thought like it's a great tool for, you know, starting your design process. It's like really like taking things a lot, like cutting, like making things a lot faster. So I think like cutting like time and all. So I thought it's a really useful tool for everyone to kind of get into it. So let me just try to share my screen. Okay. So let's go. Yeah, I think you guys should be able to see my screen.
Yeah, all
So
good.
yeah, thanks. Okay, for those that don't have any experience with AI, so basically like what we're trying to do here is using like a image generation prompting AI that I think essentially what it does is takes like what it can get like out there like on the internet and kind of sort of get a database of things, and using the text you can prompt them. So like these are some of the examples I was doing. So what happens is that, okay, in this particular AI that I'm using is called MidJourney. So there are a few. DALL-E is the other popular one. I think Stable Diffusion as well. So this is just the one I'm using. They have a little bit differences here and there, but mostly it mainly works by giving a text prompt. So for example, it says like imagine for example a like sneaker design, for example like Zaha Hadid. So that's basically that's how it works. So you put in a prompt and it will generate. And with this MidJourney bot is that, there's a few different options other than the first one I'm using is imagine. So you just type in the prompt. The other thing you can also do is to put in an image, and then you can use it at the same time. So for example, with this, so you have a little bit more influence with an input. So let's just say if I find an image, for example, I'm adding this image in. So what I can do is I send the image in from like my desktop, and you could copy link, and then you do the slash, and by clicking imagine, you get the typing the prompt, right? So it's almost the same as what I have previously, but instead of just like typing only, you could like input the link. You can input the link and then you put in your prompt, like space, and you put in your prompt. What that does is actually it helps to have already a like starting design or image that you want to work with, and then have the prompt working on it. So it will be able to kind of generate something that's a blend between your prompt and the image input you have. So that way you can have more control over it instead of having something like completely random. So like these are like some of the potential strategies that can be used. So I just wanted to share like my way of like doing it. And of course, like there's so many ways of like trying to get designs out. So for me, I think I use it as a more kind of expensive like way of looking at design possibilities. So for example, I use it in a way that's more suggestive, because I see like in general like people do like prompts with a lot of like specification, but I don't do that. I try to make it really broad, so like the AI kind of do a lot of the creative thinking. And then like sometimes I think for me it's more interesting to kind of be able to generate ideas or like results that you don't expect. So with that, and see something modeling. Yeah, maybe I can. So in this case, let me just show you some of the results. So okay, so you can see it from the two results, right? So for example, the first one is just a prompt. So sneaker designed by Zaha Hadid, for example. So you kind of see sort of like the style, but if you were to input a image, which is like the shoe, this shoe, this Oakley shoe, it kind of gives it more, direction. So you kind of get this design, and it's kind of starting to looks pretty good. I think the new version of this, the updated version of this AI is actually works pretty well. So, you could work with something like that that's more direct, but like what I find interesting is something that's, more speculative. So let me share I did like a short, like a few page presentation that we can look at. And then maybe we could like do some prompts if you guys you guys can suggest and I can like do some prompt and we could like see what results that we get. So one of the ones, let me change just screen real quick. So one of the can you guys see in full screen? Oh, okay. Sorry, I think like the full screen is not working, so I'll just like share it as it is, but I think you still can see. So sorry, Alex, you were saying that you couldn't add a picture in Discord from the desk. One way for you to do it is if you Google an image, for example, you Google that image, you right click and it says that, you know, copy image link address. That would work also. So you could also try that, finding that image online and you right click and, you know, you right click and you should be able to, you know, and it should say that one of the option would say copy link from copy image link address or something along the lines, and you can get like sort of like a link through that. So I guess you guys can see my presentation slide. So with this is, you know, this like to me, like this designs kind of look like what I said, more speculative, and you can see that, you know, it comes with really like interesting like background, even like the background and setting. And like I started doing AI like probably sometime last year when, you know, it started like when it first started, I was using it a lot and I didn't get this kind of result. And I think throughout like a lot of testing, eventually I got to a result where I think it's convincing in terms of a concept you could see, and it almost creates a world that, you know, you could really see where the design lives in. So I think that's really I feel it's inspiring when I do my work. So I thought I wanted to share this with you. And if you look at the bottom left, you can see the that's the prompt. Actually, the prompt is actually really simple. So it says otherworldly sneakers that emerge from the Pandorian biosphere of movie Avatar. I mean, I guess everyone is, I guess, somewhat familiar or, you know, of the movie Avatar. So with me, like what I'm interested in is also about like nature and technology. So I think like looking at this kind of like you know, Avatar has kind of rich world of like the story. So I think like doing that as an input, and I think there are probably a lot of images that's relating to Avatar, like movies and all. I think it helps to kind of generate a kind of world of design as well. So with like this simple, like, because I always see people have really long really long prompts and really specific. I don't know like how effective is it. For me, like sometimes the more words you put in, it makes things more complicated. So like in design we kind of say like less is more. So I think in this case it applies in a good sense. So that's what I did. So you can see like different variation of the design, and you can see like really rich textures. And this could like potentially be able to, you know, inspire you to use them, like some you can even use them as it is to model them, or you could take parts of it, which is like what I do most of the time, and, you know, integrate them into your design, and that would help. Like usually that's what I do. And And the next ones are like, so like I'm really interested in movies, right? So I thought that looking at the design in terms of the movie kind of setting is quite helpful or interesting. So if you look at those sort of like the one on the left is otherworldly laceless sneakers that emerged from the movie Alien. So you could see sort of like the ribbings on the the shoes kind of reminds you of I guess like some of the biomimicry, not biomimicry, like kind of the alien with kind of like the rib forms. You can see like almost like the bone structure on the alien. So I guess sort of like kind of reminds you of that. And also that Reebok shoe. I'm not sure if you guys are familiar, but Reebok did a shoe for the Alien movie. So I think that's sort of reminiscent of that. And then the other one is like otherworldly space boot that are partially AI that have emerged from the drama series Westworld and the movie Dune Redshift Render. So with this, it's sort of like, of course, like taking combinations of like different worlds would give you quite interesting or rich results. So I think like the series from Westworld, the drama series, I'm not sure if you have watched, but it's about like artificial intelligence as well. And the movie Dune, I guess like you probably have heard of it. It's also very interesting. That's why you see sort of like the setting in kind of like the like sand or desert. So this is like these are image prompts that is purely just word based without any like mixture of like without having me inputting like images. So you can see like it's more like open in terms of what you can get. So it's less restrictive. But if you want something that's more direct, you have something specific in mind, what you could do is also input an image. So if you can see this, the next page. So with this on the top left hand side, you can see this is the image Oakley sneakers that I added in, and like the on the bottom right, I put Oakley shoes in biomorphism style, minimalistic design, 3D render. So it kind of resembles the original shoe, but you see that it has some variations, and on the right, I put like deep ocean cybernetic coral shoe 3D printed, Unreal Engine 3D render, which for now I think maybe like specifying what kind of render maybe doesn't matter that much. Yeah, I feel like with like the previous one, you also see that, like I didn't even put like what engine it renders in. So sometimes might not be that helpful. So like having the idea is probably the most important thing in getting the results quick, I think, without kind of overthinking like what thing to put and making it too complicated. So like with this, you can also see sort of like the resemblance with that shoe, with the Oakley shoe, but at the same time, you kind of see more exaggerated design. So I think that's because of the prompt. So I think with that, I think it's quite straightforward with this. And should we maybe try one or maybe two prompts, and we can kind of maybe do an interactive one together. If you wanna suggest something, maybe we could do. I was thinking of doing something along the lines of movies. So with that, I was thinking maybe we could for example, maybe give me a movie name, and I can yeah, if anyone wants to suggest a movie name, or I'll pick something out and we can just input that like the way we did, like the way I typed in. So it would be interesting. Okay, let me check. Let me share my sorry, give me one quick second to share screen and other. Okay. Worldly sneakers that emerged from the world of I saw someone like suggesting let me see Blade Runner, Akira, or Wes Anderson, Mario movie, Kill Bill, Fifth Element. Okay, let me try Blade Runner from the movie Blade. Let's see, Runner. Worldly. Usually I like laceless. I think it's more, in some sense, it's more futuristic. So let me see. Wakanda. Let's try this first, and after that, maybe we could mesh like two worlds together or two movies together. Maybe you guys want to suggest two movies that could be like really different, and then we can see like what is the like end result. That could be interesting. Let me try maybe. Oops, I have a typo. Oh, Predator and Barbie. Yeah, cool work. Yeah, I mean, like movie is just sort of like a category that's easy to kind of like imagine, right? But you could also like do different categories, and kind of like that ritual will help inform what the shoe or footwear will look like, which can be pretty fun. Yeah, I think we got some pretty oh, this is pretty good results. So we've got this. Okay, let me try to also another thing you could also do is for example, I think this one is cool. For example, this one. So this is like, oh yes, for those that it's your first time seeing this, what you could also do is see that's U 1, 2, 3, 4. U is increasing the resolution. So if you were to, for example, 1, 2, 3, 4, what you represent is this is 1, 2, 3, 4. If you click on, for example, I want U2, if you click on this, it will increase the resolution and only focus on this one image. And for example, if I like this shoe, U2, I can also create more variation based on this design to fine tune. So for example, this is like this shoe, you could also re-input a different from, but you want to keep it the same is also possible. So how about let's do Westworld plus cars and put it into Westworld and movie, I guess movie cars, and see what happens. Ooh, so this is pretty cool. I think this is Barbie and Alien, so I guess you get like more I guess you can get like some form that are reminiscent of like especially the soul and outsole that's more, you know, like aggressive looking. And also like the knit looks a bit like the knit pattern looks a bit aggressive. But I mean it's in pink, so I guess like kind of makes sense, right? So that's quite cool, kind of meshing things up. And this is from the U button, U2. I think it's increasing the resolution. So you get sort of like higher resolution with this, which is quite cool. I think this design. And this is the one making variation of this design. So I just input like Westworld and the movie Cars. I'm not sure how much it got from like Cars, but I think probably it doesn't deviate too much from that first image. That's why this is like that. But I think we get some pretty cool like knit pattern and what. And this, you know, it's I would say this way of like prompting is, you know, faster and you know, you get more unexpected results. So that's cool. And maybe we could try variation of this alien one. Maybe I guess maybe this one looks okay. Let me see. 1, 2, maybe 3 and 1. And then let's do one more. Anyone wants to suggest more like different movies from like 2 different movies that I'll add? If not, I'll just pick from whatever that's, you know, inside that's suggested. Interstellar plus Sonic. Let's see. Oh, Alice in Wonderland and Death Stranding. Death Stranding is a game, right? Okay, could be cool. Oh, Star Wars and Charlie Chocolate Factory. Sorry. Okay, maybe we can see some result. And Nata, maybe I can I think I disabled the file for like on the upper pattern. So did you already disable that? Maybe we can, maybe I can look at the file again and see if there's any problem with mine, and I'll check back with you later. Okay, so I think this is pretty cool with the Predator and Barbie one. I think this is really cool, like with like this like kind of aggressive texturing and kind of like that heel cup. So I thought yeah, this could work quite well. And then this variation is, I think it's almost the same for this. So this is still, about the same. So it's all right. Then let's maybe do one last one. Let's do, let me see. Let's do something that's iconic. Maybe Jurassic Park and Toy Story. Jurassic Park and Toy Story. And let's do Star Wars and Charlie and the Chocolate Factory. Interesting. Maybe let's not do laceless and see. We could do other categories, maybe boots. Cool. Oh, they all look like Ultra Boost somehow. Maybe it's the laceless thing. I'll try it without the laceless. Maybe hiking shoe. Oh, yeah. Yeah, this more like a van. So sometimes it doesn't work so well. So you have to, I think this looks more like a conventional like sneaker with, I guess, like dinosaur prints. So sometimes changing the category of the shoe would help, like laceless sneaker, you change it to hiking shoe, and Star Wars and Charlie Chocolate Factory. Let me try from laceless sneaker to boots. What kind of boots? Let's try rubber boots. 3D printed boots. How about that? Oh, this is cool. So yeah, this is the hiking shoe from Star Wars and Charlie and the Chocolate Factory. This is quite cool, but I think nothing that's not, I guess, like more conventional look. So this is one thing, and let's see. Where's the other prompt? Maybe. Okay, let's try. Maybe we can try one last one. Jurassic Park and Transformer. Maybe. Oh, let's do. Okay. Yes, you'll be able to do like something like, I guess instead of haha, you meant Zaha Hadid and Neri Oxman. Yes, you can definitely do that. Yeah, you can do that as a prompt for sure. This might be, oh, this looks quite promising. Jurassic Park and Transformer. I guess this sort of like has a Transformer look. Almost like has that logo there. I guess it's a good in between that's more kind of mechanical, and I guess some parts are looking organic, and you have like sort of like a forest or jungle background. So this is cool. Yeah, you could definitely do, I think you can definitely do something that you quote like designers like for example Zaha Hadid, Neri Oxman. The thing is, I think most of people are doing that because like you're looking at design, right? So the most direct thing you would do is to quote designers. But like from what my experience is, like I kind of did that quite a lot. Then I realized that if you look further out into different like sources of inspiration, you get more interesting designs. For example, let me just scroll and show you like what I have before. I did so these are like hiking shoes, and let me show you like the ones that I did that's like maybe more like, for example, yeah, for example, like Ross Love Groove and Zaha, you get something like that, which is cool and all, but it's definitely more expected result. So you want to be able to kind of create something that is kind of expands your option. So I will kind of look like outside, or even like a combination of like something, for example, I just did like easy in collaboration with Mason Margiela. So like these are like some of the options, which is like pretty cool. This, for example. So yeah, something like that. So I think all in all, yeah, Ross Lovegrove and William Morris would be a good one. But all in all, what I'm trying to suggest is that this is a great tool that you could use for designers, and then you could pick out what you like and put that into your design, or you could just almost take the whole thing. So I think that's more or less it. And one more thing you can do if you're not familiar is that there's something called describe. I'll just go through that real quick. Describe is basically, it works the other way around. So instead of putting in a prompt and getting an image, you put in an image and it returns you the prompt. So you can kind of learn about how the AI works, or what do you need to kind of suggest for it to get the right images. So like the kind of possibilities are endless, and especially I think moving forward, you probably be able to get. I think moving forward, we'll be able to get not just image, but I think like starting to get more 3D. So you might not even have to, do 3D in future. So you can see, for example, blue. So we can, you can almost type in the same prompt, and you can see, like, maybe you can see the kind of results, and you could tweak it depending on how you want it to be. I think press for, oh yeah, it does. Yeah, so when you click the number, it will give you a prompt. It will generate the prompt. But it doesn't always work perfectly, which might be good depending on like how you're gonna use it. So I think with this, more or less, I will kind of end. This is more of like a kind of introduction into like how you might be able to use it into your workflow. And maybe after this, we can have a 10-minute break. In 5 minutes time, I can look at some question as well. Okay, Mohammed, does English by regions affect its prompt? I think it does. I think the same way when you key in trainers, I think the way I would think about it is like if you Google like trainers if you Google trainers versus sneakers, like the result you get is similar but slightly different depending on where it's used. So I think it would skew a little bit slightly, potentially, but I've not like extensively tried it to know for sure. But I think it's something you can experiment for sure. I do also try different things, like instead of sneaker, I put wearable sculpture just to get a different kind of prompt. Like foot wearable sculpture is sort of like it's a description of a shoe, but it's not a shoe. So I would sometimes play word to get something that's different, or get something that I want in that sense that's not so direct. So I mean, if you see this shoe and the end of the result prompt, like the colors are similar, but the design is not same, but still pretty cool. So this is what you can do. So these are the results. So with that, maybe we can take a 10-minute break, and we can start at, it says it's 57 now, so we can start 07. And Mohammed, I can answer your question now. So maybe let's take a break now, and I can answer your question, Mohammed. Let me read. What's your thought process? Right. Yeah, Mohammed, your question is interesting. Let me just read your question. I think in future I should read all your questions. Was wondering what's your thought process when fashioning a footwear? Amalgamate how do you amalgamate user comfort and aesthetics? Yeah, that's a really interesting question. Usually would think about when designing something, because like when it comes to 3D printed footwear, it's kind of in some sense uncharted territory for like when I'm like, because I'm working with 3D printed footwear most of the time. I always try to include features that helps with comfort, and also having the design being more integrated, that it fulfills that function. I kind of consider function a part of the user comfort as well. So that's how I would think about the design. It's almost like I don't see it as a separate thing. It's when you think about the design, it would naturally be part of your consider part of my consideration when I'm designing, because like obviously some things won't be comfortable to wear, and like certain designs, and you know you won't be able to kind of like will not work. But anyways, let me I think the army's collection is like maybe a good example. I'll explain to you like how it kind of is a in between, like thinking between the form and how the form kind of informs the function and therefore like the comfort. So maybe you could like, we can look at the design. I'll explain a bit about the design afterwards. Then I hope that will kind of answer your question. Yeah. Most welcome. All right, see you guys in like 7 minutes from now. All right, I think we can now. It's 07. I think we can start the class now. So if at any point in time you cannot hear me, please let me know. I'll just continue. So I wanted to kind of introduce to you the design that we're going to work on today. So let me share the screen. Yeah. I think it doesn't work so well when I do it like full screen mode. So I'll just share it like that, but I think you can still see it. Basically, this design is actually already what I'm working on for my brand. So my brand is called Alive Form. If you don't know about it already, but basically we are a fully 3D printed footwear brand, and we're kind of looking into the theme of nature and future. So kind of like inspired by nature, like growth, for example, growth algorithms or like patterns and like structures from nature, and trying to integrate them into the design and kind of have a more kind of futuristic outlook in terms of like the way we make it, like 3D printing, and how we can push boundaries and how we can expand the scope of like footwear design. Because I think like with 3D printing it's sort of like an uncharted territory, and a lot of things that we design, we have to think about ways to realize that. And with more traditional like sneakers or footwear, you are more restricted with that form. But with 3D printing, you sort of like all of a sudden you're kind of released with a lot more like design possibilities. Of course, there's still consideration that you need to look at when 3D printing specific to the technology or like the printer, but all in all, you get more like, I guess, design freedom, which is quite exciting. So I hope you guys are kind of excited about this as I am. So Lifeform is my brand, so you could visit the website. Let me just explain the design first. So this design is called Armis. So Armis in Latin translate to armor. So I was really interested about the creation of nature-inspired protective forms. So for example, the cactus, you can see that in the inspiration, and also seashells. So I think, Mohammed, you were asking me earlier about the question about how I amalgamate. So for example, this is one of the way I look at it. Having the shoe itself, you sort of have a foot, right? But the idea of the shoe essentially is there to help protect your feet, right? So I think one is comfort and the other one is protection. So it has that function, right? So I was thinking like in terms of this manner, like in nature, where do we find like similar similar logic kind of thing? So you see that in like shell and like cactus, for example, the kind of harder exterior protecting like the softer, the like maybe the organs and the cells inside. So with this shoe, I also look at it as like a feet, like your foot, right? And having sort of this kind of, you can see the design already. You can see on the right hand side, you see all these patterns that's covering up the leg. So those kind of becomes the functional part of it, where it sort of like wraps around the foot and sort of protects the foot. So that's kind of like the whole idea. And this design is also an evolution from a previous design I have. You can see the slide in white. So that's that, you have these layers of like panels, like really like organic panels that's covering the different areas, providing like, coverage for like the shoe itself. And maybe I can show you guys if you look at me on the screen, I can show you the shoe. Let me see. maybe I can stop sharing a little bit and I can show you the shoe. I think it always helps. You can see the shoe here, right? So let me just show you all the different views of the shoe. Then I can explain a little bit. So you can see like that's the back and that's the medial side. But basically what you have here is you imagine your feet and then you have this structure kind of like wrapping around your feet. And then on the sides, it kind of like provide coverage and, with for example, the Adidas shell toe superstar, I guess like you would probably be familiar. It also has that shell toe, right? So this is sort of like similar to that where you don't like kick your leg into something. So that's like that kind of level of function. And then this is more protective, right? Then on the bottom, so this becomes part of the cushion and traction. So this design has also this like different level of like, I guess, like functionality. We are looking at like this pattern having to protect you, but this pattern also having that traction pattern and provide that cushioning as well for your foot. So all in all, it's really thinking about it in this kind of way and having a little bit different way of approaching footwear instead of just a more standard sort of footwear. And for let me just answer a question real quick. For Davide, like the resin I use is I have a manufacturing company that's helping me handle, and the resin I make is proprietary from them. So I don't have any preference because I don't print it. So they have their own printers and they have their own like resin as well and technology. Then as for Jonathan, like what would you consider the biggest constraint in 3D printing considering what you just said? I think I wouldn't say it's like a constraint. I would look at it more of, how programmers say it's a feature, not a bug. So I would try to think of it in this sense. It's a feature. You can design a lot of complicated structures. You just need to know how to make it printable, or you need to know enough. How can I say? You need to know enough in order to design for it to be printable, or you find different ways to make your design printable. So it's more of understanding the technology, and then you understand how to design for it to be printable, or you figure different strategy to make it printable. So yeah. And the inside is, sorry, let me just show you the inside. You cannot really see the inside, but inside is lattice. When I actually approach the design, I'll be able to show you that in the 3D, but you cannot see it here. But what's here also, I didn't add this into the like geometry because this is quite simple. So this is sort of like something that's mimicking a cushion. Where in the shoes that you usually wear, there's a collar cushion, and that helps lock in your heel and provides a little bit of comfort. But when you look at 3D printed footwear, you don't really have something like that, right? So we kind of had to figure and try to invent. So this kind of like a webbing mesh lattice kind of thing, kind of has that same function. So it's a little bit squishy, but helps lock your feet in and provide a little bit of comfort. So yeah, basically that's the shoe. And let me share screen, continue sharing screen. So the next page is, so this is the Army's collection. So what you just saw is actually the low version. So there's 4 variations. So there's the low plus, which like the thicker sole, the mid, and the slide. And there's the packaging. I won't go too much into detail, but basically these are available on the website if you are interested. If you are interested in ordering, you can contact me. I'll send you a free shipping coupon discount if you are keen. So it's available on aliveform.bio. You can check it out. So also with that, I just wanted to show like a couple of like images for the mood board and not mood board, sorry, like the photo shoot that I did. So we did this like photo shoot with like 3D CGI background. So just to show you before we start a little bit here and there. So yeah, then let me start getting into the design. So, okay, I see there's a lot of questions. Let me quickly answer a question. So Neta, do you need to? You don't need to do, okay, so with sizes, there's a metric where you size them differently in scale, in a non-uniform scale, specific to like the shoe sizes. So you don't, I'm not sure how you will need different, yeah, I guess you will need different files for that. Yeah. The inside, is it made, the inside Giovanni, the inside, is it made for an optimal about load? I guess that with that it comes with a lot of like testing, and you can I'll you can see on the, I'll explain later in the design where you could do variation. For example, your back foot kind of takes more weight, so you could like increase the density of like the lattice to provide more support. So you can optimize that way. You can have like variable like density, or strategically placing like more density in certain areas. Alex, how much space do you need with this material between the foot and ground to preserve comfort? I think in general, like, I guess, yeah, someone asking about the stack height, which is the thickness of the midsole. So I think the thickest of the midsole would be around, I think you need about like 20 millimeters like in height for it to be comfortable at the heel area, which is like the thickest part where it should be. Then what are fundamental functions that you go through when you design a shoe, like compression regions? I think like areas that, you know, that help enhance comfort, like that heel cushion that I said, and also yeah, like compression regions like you said. So I think like with comfort functions, I think those are the two maybe main ones, and also the way you wear them to be comfortable. But a lot has got to do with like actually printing and testing the shoe, and then you get a conclusion and you see how to improve based on that. So like we're still like continually improving our shoe as we go on. But yeah. Is the shoe printed from powder resin or liquid photo sensitive resin? It's like yeah, it's photosensitive resin. Oh, the mesh distribute. You mean the mesh distribution? I'm answering the Q&A now. If you guys are not aware of what I'm doing, the mesh distribution. Yeah, so like with the mesh distribution, like I said, it's also the same. It has to be something that you test out, because I realized depending on the design, it doesn't always work the same way. So it can change. So some can have a very even distribution, some designs, and some other designs, you need some areas to be denser. So it all would, so in the end, what I meant is that you do have to test, because every design, or like not every design will be the same. What kind of printer do you use? The printer is proprietary. It's just a printer that like a company that I work with. I'm not it's their own printer because I don't think they sell their own printer, so I'm not exactly sure what printers that they work with. Yeah. Okay, let me get into and now let me get into the actual 3D portion of modeling of it. So if you guys can open the Rhino file and Grasshopper file that I sent you. And let me share the screen for that. Okay. I think I need to show this. Okay. If you look at the files, let's go through the Rhino layers first, so we know what files are inside. So we can look at design. So with design, look at the top view. You could zoom in. So this is the kind of organization of how we're gonna approach the design. So this is the design, right? So what we'll do is we'll look at the pufferfish pattern. So like this, like individual, no, these groups of like patterns / structure is done in like the pufferfish plugin. So I would kind of focus first on that, on how to create this to pufferfish. Next, this upper pattern. So I did like few variations. So there's some like small, more detailing pattern, like texture on the shoe. So I'll show you how to do that as well. Then lastly, you could see the lattice here. Okay, maybe let me just full screen. Okay. So yeah, let me just show you here. So same thing, pufferfish pattern here, and then the upper pattern. So first, second, then third, we'll be looking at. I have a few different strategies for applying like lattice. So you could look at them and then you can see like which one you would like to use more. I mean, you can experiment and see what works the best for you. So yeah. Okay, let me turn that off. And then we have the last. So with all shoes, all footwear, you need to start with a last. So basically a last is a shape of your foot that has they have a certain standard size and measurement. And of course there's different lasts out there, but that is sort of like a standardization of like the different foot sizes, and you use this as a basis to create your footwear. So if you are looking more into actually creating like functional footwear, this is what you need to know about. So this is a last, then this is so the last is in subdivision, and then this is also a subdivision. So this is including if you see in the right view, so you can see I usually work in a way that I get the last, then I try to build a exterior, including the midsole. So you sort of have the form of the shoe already. Followed by, so I have this I call cutter, but what it is just, you can see sort of like, you can sort of see the semblance of the logic where how it works, whereby I cut it into different sections to create the pattern. So that's that. So like the cutting is already done, it's already in the Grasshopper layer. So with Grasshopper, you could look, there's quite a few layers. So we have like network curves. So this curves is used to replicate the layers. So okay, you can see here, it's easier. So these curves is used to replicate this. So the rationale for doing that, and to apply in Pufferfish, is that with Pufferfish plugin, okay, maybe you can look at the plugin real quick so it's easy to understand. with the plugin, you will need, it's called Twisted Box through surfaces. So you need to be able to put in a pair of surface and it will create the twisted box. So in order for one of these important component to work, we need to have surfaces. And these individual parts, although trimmed out, right? So they are nice, but they are not actually surfaces, they are poly surfaces. So you cannot actually use it. And also the way it works is that you need clean surfaces so it understands the topology of the surface, and then the twisted box or the component is able to map out the pattern correctly. Because with a surface, you sort of have a U and V, right? So it knows where to follow in terms of direction. So that's important. So we are sort of like trimming and kind of recreating the surface with curves. Are you guys familiar with network curves? Sorry, network surface, not network curves. Yes, it's in the layers of the Rhino, not the Grasshopper. So yeah, remember to turn on that. So sorry, I was saying I hope you guys are like familiar with that, but it's basically a function that you can also use in just natively in Rhino. I'm gonna use that curves and put that in Grasshopper, but you can use it natively. So it's called network surface, or rather curve network. So you could see like these are very clean topology. Here, let me just highlight that and move that. So you can see all the, all the curves are, sorry, not curves, the U and V are arranged, not in this sense. If this is the individual like shapes, they're all broken up into, because when you create broken up individually into like individual surface, like small panels of surfaces, because you are using sub-D. So in order to kind of make it into one singular surface for it to work, you need to kind of use that. So that's kind of like the logic behind why this exists. And then you have the pattern. So these are the pattern. So these are the pattern you apply. So you see on the sides, that's the pattern, right? So these are what you can customize and add it inside so that it kind of morphs and shapes differently depending on how you want them to be. And then this is the sole portion of it. So what this does is that, it takes the negative space out of this. So basically what this is the difference between like the purple and the blue part. And what it gives you is the volume for the sole. So that's where you fill the lattice with. And then you have the upper. So we can use this as an input to create the pattern. And then with the last armis is pattern, it's upper, but it's like a thickened upper, so it has a thickness. So this is the actual like thickness you would use. So yeah, with that, let me just get into Grasshopper. What should I do? Okay, maybe it's better that I yeah, it's similar like loft, but in a more controlled way. Yeah, loft gives you a clean surface, similar to this with kind of like the UV align, but loft you have a more maybe limited shape, but with this you have more control exactly. So maybe I'll explain this with the components set in already, and I'll just turn them on one by one, and you can look at them, and if you have questions, you can ask me. So first, like, let me explain the strategy of how to kind of realize this. So first, we can look at the most important thing is the pattern we want to make, right? And it is made from pufferfish. Usually the way I look at how to create my shape is to look at the main component I want to use, then I work back into what I need to input that in order to get the right input and result, right? So with pufferfish, you can look, this is the component I'm trying to use. So twisted box through surfaces. So what this does, it between, for example, that you can be a few surfaces, but I'm using just two. So when you have two sort of like surfaces with a gap in between, I want to populate like boxes in between, and then you could have the pattern kind of layered inside them. So some of the input you will need is like surfaces, then you have like different parameters, but like most important is surfaces. So with this, just with what I have, I cannot input them. I cannot use them as it is. So I had to have something that's similar. I cannot use them as it is, so I have to have something that I can use them as surfaces. So that's why we need to do sort of like a network surface in order to recreate them in surface. So that's what I'm trying to do. So with that, we have the network surface. I'll try to explain the logic of how this works. So hopefully that kind of makes sense. So this curve, for example, let's look at this. So this curve is split into a few. So let me just turn that on real quick so you can understand how it works. Let me isolate this. Ungroup it. So you could see like network surface work like that. So how it works is that you take the boundary edges and you split them typically into 4, not 3. This is maybe a little bit more unique case. 3 and then you can create a surface. So with this, sometimes you need to input like cross-section curves. Let me show you. You need to have like cross-section curve, for example, this one, because it gives you a more accurate result. So it gives you more, how can I say, more information for the surface to be created. So you create this, so it knows like from the side view and kind of left, right view and front, back view, how it should be. So that's why you input more curves. So let me set this. So I would set these curves. And this is automatic network surface. This is from Pufferfish as well. I think it's somewhere here, automatic network surface. So it works the same as not component. I think component from Rhino, but instead of having to click one by one, it helps you sort out, which is really helpful. So I like using this quite a lot because this way, if you tweak your curves, it will be still updated here. So you don't have to create the surface and bring it inside. It's very useful because you can tweak the curves on the fly and just kind of update the curves, and you kind of be reflected. And this is next is adjust UV. Like for now, you don't really see the use for it, but I'll explain like what it is for afterwards. So with this, you'll get the surface already. So if you can turn it on, you'll see the surface. And then we'll have another problem with this. You see like this surface a bit odd, right? It's kind of concave. But if you see this, original surface, it's more convex. So there's a little bit of like difference in that, and we need to, because like it needs to go on the shoe itself, so it needs to be accurate. With this, it's quite the network surface gives you a good kind of estimation of where the surface is, but it's not as accurate as I would like it to be. So in this case, like the way to kind of resolve that is actually to divide the surface. So I'm dividing the surface and taking these little points. So I divide them into like 30 and 30, and taking these points, and I try to project it back to the original surface. So this input is the original surface. So with that, let me turn on this like closest point. So you can see the curves moves right from here to here, because this is where I want it to be, where the actual poly surface is. So we try to project that there. So let me turn this off. So after finding the curves, after finding the closest point, you can then rebuild the surface. So you could build the surface from points. So you need the U count, which is what you input here, but you need to add an addition of 1. The logic is that when you divide the points, when you do a division of points, you don't actually count the end, start and end of it. So you actually need 1 more. You divide in the middle, so you need 1 more for it to work. So after that, you'll be able to get a surface that's a lot closer to the original one. So this is the surface before. So you can see the gap. There's a gap here. And this is not, it's sort of like an estimation, but it's not as accurate. But when you do this, you get quite an accurate representation of the poly surface previously. So you get a kind of clean surface here. And let me answer a little bit of the question. Jonathan, you asked where the files. The files should be sent to you over in email. So maybe you could check your email real quick. Victoria, where do you get the last of the 3D models? So I got the last from, you can get digital last from a shoemaker, or someone or you could like scan a real shoe last and use it. So this shoe last, I got it originally as a 3D model. So it's probably scanned from a real shoe last, and I did some tweaking based on my needs. Rest, your design layer in Rhino is empty. I think you can, it's empty. I think you need to click the show button, or you need to unhide. Either you type in show, or you need to click the light bulb, because I think they should be inside. Design 1 is yes, Res, the design 1 is just a you should see it from the top view. It's just a reference of the, it's an image reference of the design and how we're going to approach it. So there's no geometry in it. It's just a, like the image. Right. I think the image might not be saved. I can send you guys the image again. So yeah, so bear with me on that. Jonathan, does the ISO curve density, I think you mean the density of the points spread out? I think it does. Like with more density, you get more accuracy, but you get, I think, a more complex, or maybe a potentially a more heavier surface, but it does affect, and the direction as well. I think the direction is more on the surface creator. I'll explain maybe more on that later if you see. A little bit more on that where I explain about like adjust UV. I think that would impact the kind of modeling itself. Okay. Okay. Yes, let me try to make it maybe half and half so you can see it properly. Maybe this is better. Yeah, I hope this is better. View experience wise. Right. How do you draw the 3D curves to create the network? Are you putting? How do you draw the 3D curves to create the network? Okay, the 3D curves. The 3D curves. You see, there's the cutter, right? That I placed, and then there's the sub D here. So basically it's trimmed out. And after that, you can just duplicate the edge. So you basically get this after you trim it out. And when you duplicate the edge, you could just do this, right? You could Shift Command for Mac. I'm not sure if you are using Windows, maybe it's Shift Control. So if you double click on the edge, it would do, it would select the whole edge and you could duplicate the edge. So you get the edge. And what I did is to split the edge. So you get the whole edge, but where you split it will affect how the surface is formed, and also even ultimately affect how the pattern is being distributed on the surface. Because imagine, for example, this is a U and this V, right? For example, the direction is like that. So the pattern will be kind of spread across in this manner, or maybe this manner, depending on how you set it. But imagine if you do it in a different way, for example, you split the curve in a different way, it might be diagonal across. So it really is dependent on like taking the curves where you end it will affect where it's constructed. Let me see. Okay. Right. Hala, let me answer you the question when we're about to have a break. So with this network surface, okay. So we are done with this. So the logic is to get a surface, right? So we already got a surface here. And then in order for the surface to work, in order for the pufferfish component to work, you need to have two surfaces. So imagine this. Let me show you. So you need to have something like that. Isolate that. so I can illustrate how it works. Then, you know, the pufferfish will have an input between this and this. Then it is able to project or populate a pattern between these two surfaces. So it needs an input for that. But imagine if you see the shoe itself, if you were to project a pattern over here, it would be, you know, straight out. So let me show you which won't be as nice. So you ideally, you don't want it to come like, you don't want the pattern to come out aggressively like that, right? Like the idea is to have it sort of like a curve, to have a curvature. So almost like a fillet or like around the edge, so that it's not so harsh, the pattern. So we want to create a surface that's sort of like a clamshell, like that. So let me show you, and then it's maybe easier to understand. So with that, we need to offset the surface. So with this, you kind of have an offset surface, and then you see, I'll just like explain in a general manner so you understand. So this is a graph mapper. So this helps create sort of that transition between sort of like a varied height. So this is the highest, and towards the edge, you'll go lower. So you get a smoother kind of pattern that doesn't just juts out like from the start. So same thing, we kind of want to have a let me just turn this on so I can explain. So we kind of want to project the points outwards, but we want to have this area like closer to the edge and the ones in the middle more projected outwards. So we start by extracting the B-rep edges, and then we kind of divide them into like the control points. And then we find out where the closest points are in the cloud. So, and then we get the distance between, let me show you where this point is so it's easier to understand. So basically we are trying to take all these points, and then towards the edges, it should be closer, smaller. So we kind of construct a domain here. Basically what we are trying to do is to get the distance. And then basically what we're trying to do is project them in a certain distance. And when you have a graph mapper, you can choose from the edge that's the closest, and you want them towards the edge where it's the closest, you want them to be shorter, right? So in order to do that, we have to find out, how can I explain better? So for example, from here to here, it's further, right? But for example, here to here, it's the closest. So we need sort of like an input to know how much thicker, how much to sort of like offset the points. So we need like a marker. So in order to do that, we take the edges, the points. So we just divide them. We take the points and we kind of get the closest points from here and use that as a marker. So we get the distance between these two. So the closer it is, the smaller the number, and the further it is, the wider number. So we know like where should go like further and closer. So we have a control over that. So we create so after finding out the distance, like what I explained earlier, so then you know like where is your control, and then you kind of put them in the bound. So we basically map this into a graph mapper. So the way I do it is usually graph mapper start with 0 and 1. You can tweak this number to exactly the distance that you want. So for example, the bound is 0 to 20, but I prefer to keep it to 0 to 1. So in order to do that, I need to take the value, the distance, and then remap the numbers into a 0 to 1 domain. So I start with 0.01 and 1 instead of 0, because if you use 0, the pufferfish wouldn't work because it's completely 0. So the twisted box will be, for those that are not familiar with twisted box, basically it's sort of a mechanism to kind of apply the pattern into. So let me explain first, move on with this first, then I'll come back and explain. It's easier to understand. So with this, you get the numbers and you remap these numbers from the distance, right? So you can get the bounds is 0 to 20.1. So from here to here, the closest point from here to here is actually 20. So somewhere in the middle is probably the furthest. So that's 20. And the points at the edge would be 0, right? Because it's like the same points. So you map them to 0. We map them to 0 and 1. And then you put them into a graph mapper. I'll show you the rationale for doing that. And then you have and then there's an offset of surface. So first you need this. So this is used to give you a direction of how much it should extrude, and the other one, when I offset surface, is the direction it should go. So first one, this is used to inform how much to extrude with the graph mapper, and this one on top, it offsets it. So this helps to give a direction. So you get a point. So basically what this does is from here to here, it would create a vector. So with this vector, you know, this is the direction I'm projecting the points towards. So you use this as a vector to project the points, and then you use this as a amplitude. So like this would denote how much to project the points. So with this, after adding this, that means that this amount, the points over here would be kind of projected at a smaller length than the points over here. That's why we are trying to get the distance between here and the middle and the edge. So we know at the middle you kind of project the most, at the edge you project the least. So I think now this is like the easiest way to understand. So you can see towards here, the points sort of like move like non-uniformly. So like towards the center, it projects out more, and towards the edge, it's just really close to the points, really close to the edge, sorry, original edge. And with this, you can also, adjust. So this actually affects the curvature. So this curvature is actually reflected here. So if you tweak it like that, for example, it would be modified. And with this, it's gonna make like a really the cross section of the curve will be modified and kind of mimic this. So Graph Mapper is quite useful in terms of getting control, and you get a surface. So you sort of get like a clamshell surface. So it kind of, from the center is higher. And then with this, you can control the height. The way you do it is by this, I put like a multiplication. So in order to, increase it, just like put in a higher number, and to reduce it, just, put 3. So you have more control over this. So with this, you get this two surface, which is the essential input for getting the pufferfish twisted box through surface to work. Let me show you the result quickly. So this is what you get. This is it's not. Turn this off. So this is what you get. So essentially, this is a twisted box, but what you can imagine this is these individual boxes is what will be used to, what you'll use the units to, the pattern to populate. So like this is the pattern. This is the first pattern. So I created this pattern, highlight that in, sorry, not this one. Let me show you sub D. Yeah, I created this in sub D, so you can just model this quite easily. And what it does is it will use this pattern and apply it into here. So what I do is use usually I will convert it into a simple mesh, because this way the geometry is lighter using mesh than other geometry than for example polysurface or surfaces too as well. So it's less heavy and process takes a shorter time. Also with sub D, I think you don't have so many options in terms of working in Grasshopper, because sub D is still relatively new, so it's not as integrated as like surfaces or mesh. So that's also one of the reasons I'm doing that. So you'll need so you can morph to twisted box. So you need a reference. A reference is this. A reference is this box. It will tell you how much this will actually fit into the exact 1 unit of the twisted box when it morphs into the shape. And the pattern I have is you can see it's slightly smaller from the top view as well. So what this means that it would keep a little bit of gap between the different patterns, doesn't stick exactly together, and you get this individual like structures. So after that, I would join them and weld them together into a mesh. And then this is subdivision. So this makes it smooth and increase the increase the mesh density. Basically is to make it smooth. So this component is from Weaverbird. Yeah, demodeling. Cat Moon Clark subdivision. And after that, I would offset the mesh to give it a thickness. And let me show you the preview here. And let me go back into like some of the variables. So with Pufferfish, let me explain a bit more about this so you know how to kind of use and control it. So with this input, there's a lot of like different inputs, but it doesn't need to be you don't need to use them all. So it makes it simpler. So what I do is I would use this, and the main input would be the surfaces, parameters U, V, and W. So if you look at it, it would say it wants something between 0 to 1. So when you divide them, for example, 0, 0.125 up to 1. So when you divide them, it knows how much how much pattern to place in between. So like 8 is this way and 10 is this way of how to repeat the pattern itself, or how dense the twisted box is. So let me see, if I do like 10, you should be able to see like denser. And with this, 10, you won't see much of a difference if I increase this. It's just simply because it's just horizontal, like almost horizontal. So it's connected anyway, so you don't see that much difference. So with this, if you do 5, you get less dense. And you do 8. And for this, because it wants a number between 0 to 1, So in order to do that, you need to use the range component, and by default, range is basically dividing the numbers, dividing a domain into steps, and you will output into 0 to 1 on a increment level. So this I will use that to input into U and V, and for W, you can just simply put 1, because we are actually only dealing with this direction and this direction. So we don't really need the W in this case, so you could just put 1. And moving back into this component, the reason why I said like this network surface, adjusting the UV is important is because when we create this automatic network surface, we don't really know how the surface is facing. So for example, if you swap it might be this in this way. Sorry. This doesn't work in this case because it's divided into the surface is constructed of 3 curves, not 4 curves, so you can't flip it. Doesn't work. But it could be potentially of a different direction, so you need to flip it. So in order to get the pattern to face the right direction, and that's like basically the nature of the surface. Let me see, guys. Yeah. So this is equivalent to, so what this UV thing is equivalent to is something like that. Let me show you. So if you put direction, like a surface is constructed with UVW, right? So it has direction, so it is a information that's baked into the surface already. So sometimes when it faces the wrong direction, your pattern would be kind of like not the way you want it to be. So in order to do that, especially because it's automatic network surface, you don't actually know how you don't 100% know where it's facing the kind of UV direction of the surface. So you need this. So in case that it's flipped, you could just like swap it and it will flip to the right direction of what you need. I think this is a little bit complicated. So if you have questions, you can ask me. Sure. Let me try to do it from the beginning. For the next ones. Do you guys have any more questions for this? Right. Okay, I understand, Jonathan and Felix. For the next one, I'll do it from scratch because I thought maybe it's a little bit easier to kind of explain like when it's done, and you can just turn on the layers and try to understand like how it is put together. Yeah, I gotta say that this is a little bit more complicated to understand because of like what you need for sure. So yeah, I think for the next ones, I would do it from scratch again. And also for the for the sub D modeling, I'm doing it through Rhino and then use that as an input for Grasshopper. And then for Kaizang, you're right. You can't use Dendro plugin on Mac. So what I do is I use VirtualBox to create a like a window OS and then run Rhino through that. Run Rhino through the Windows 10 so I can use Dendro. It's sort of like a workaround, but that's so far the only way I am able to use it. And also Dendro is quite important / useful in this case when you want to create a lattice structure. You want to create volume out of your lattice structure into a mesh. So another question. So in a way, dividing surfaces and defining UVs is a way to set up the basic framework for geometry. Yes, I think when it comes to using Pufferfish, it is important because, yeah, you're right. So it's sort of like the basic framework because it needs to know which direction to orient the pattern. So in order for that to work well, or for the plugin to understand where to place the pattern, you need this information from the surfaces, and you can use what is it called? Adjust UV to change the direction if necessary, because sometimes when you create the surface, you don't always check. So in the end, if you need to tweak, you can tweak it this way. Is the sub D model after a 3D scan? How do you make sure the proportions are correct? Yes, the sub D is modeled after 3D scan. Okay, with for example, a 3D, you can import in for example, a 3D mesh, 3D scan is a mesh, right? After you import the mesh, you can actually, you can do a quad remesh. You can do a quad remesh. You can do a quad remesh in order to get this. So the quad remesh would rebuild the quad remesh is able to quad. Let me do quad. This quad remesh, if you see here, you can actually convert to sub D. So you'll be able to kind of rebuild it into sub D. Gabriel. So the final model is made by different meshes, all divided and intersecting. Do you send the file as it is to the supplier for 3D printing, or do you join everything with a secondary Dendro process into a single massive mesh? I send it in different meshes. And I send it in different meshes. You can also do it in Dendro if you want, but I think sending in different mesh, it would still be able to print without problem. May Sam, simple. Okay, which surface you extract the curve for network surface and how? Okay, let me show you how to do it. So just now I explained briefly how I did it. Let me show you. So I mentioned that you get this. You got this trim surfaces, sorry, trim poly surface, right? So what you do is you shift command in Mac, I think shift control in Windows, you double click and you can duplicate the edge. Duplicate edge and I'll join them. After that, I will put, maybe I can show this to you guys. For example, I put these points here and I put here 1, 2, 3. I put one more point here. And then you split the curve, split using this point, and this point. And then you'll get 4 curves, right? Sorry, 3 curves. Let me put one more point. So you get 4 curves like that. And then you can use it as an input. Yeah, so after getting these curves, you can use it as an input. Let me do a second one. And then you should get your curve. So this is kind of like the basic way of doing a network surface, like a simpler one. So this works the same. And another way you could do it with more precision is you take a cross section of the curves as well. So for example, this also Command Shift or Shift Control in Windows. You can duplicate the edge here. You join it and you have one more input. And you get a more, so this will have one more information over here on how this surface would be built in this section. And what you need to know is that in order for this more like a cross-section curve to work, it needs to be, if it's in 4 parts, it needs to be the opposite. It needs to be between the opposite curves. So for example, you already opposite edges. So for example, 1, 2, 3, 4. It needs to be opposite. So it needs to be here, between here and here. It cannot be between here and here, because it's building it like that, like, you know, in a grid manner. So if it's just beside each other, it won't work. So it's building it like a grid manner. So you can also do it like that. So the other way to do it is like this curve and this curve, right? You could do one between here and here, but you know, now the poly surface edges you cannot extract in a way that will work. So what you could do is you can you can section it. So you can section this. When you section, it helps extract this curve. So this is something that's important. So this curve, cross-section curves, has to be between the opposite edge curves. So between this and this, between this and this. And then you can, you can take this input and then you can drop it in as well, all together. So you'll be able to get the curve as well with more accuracy. So this, you can see it's kind of following this cross section. So there's more accuracy, but of course it won't be 100%. So that's why you need to kind of rebuild it and rebuild it based on the trimmed surface, this one. And also with this, if you build the curves differently, the result of your pattern would be different. So let me show you. So the pattern is different here. And then you can potentially flip it. So this is what it is useful for the UV that I'm using earlier. I swap the UV, so it should go this way. But I mean, so you see it's underneath here when you swap it. So when you reverse it again, it's gonna come out on the other side. No. So it's very different from this. So there's a lot of variables that you could play with in order to get the pattern that looks nice or the one that you want. So they look different, right? Okay. Yeah, I think we can, yeah, I think this is probably might be the most tricky part of this, like most tricky part of like the whole thing. So maybe if you can have question, you can ask me, because this is also quite like maybe more fundamental into understanding like how you use surface, and then you build a good surface and you can apply it into like different like components in like in Grasshopper. So that's kind of like useful. You can ask me any questions. We can go for another 10-minute break from now, and then I can answer the questions that you have also within this 10 minutes. Then we can start like anew after that. Maybe 10 to 15 minutes, maybe we can start at 40. To 40. Okay, let me answer questions. Okay, Hala, you asked, do I use the same shoe last for different types of shoe? Example, sneaker and open toe shoe. It depends, but the last for a sandal would be different from a last from a sneaker. Usually a last for a sandal would probably be a little bit wider compared to a sneaker. So it depends on the design. And also, for example, if you want a dress shoe, it will be, sharper and narrower. So there's like different lasts for different, I think, different types of shoe for sure. So Sam, I hope I answer your question about network surface and how you could use them. So they're kind of like the building blocks of a surface, basically. Anonymous attend. Can you demonstrate the process mesh subdivision extracting curve? So I think I did that already. Why is it important to divide the curve? Gabriel, sorry. Why is it important to divide the curve to build the surface? Okay, basically the surface is built in this way. How can I explain? Surface is built in this way. Gabriel. So you will need a UV in order to build the surface. So if you see the surface topology, it's always like in this manner. So in order for this shape to fit this way of building a surface, you divide them so that it knows to build across like horizontally and vertically in this case. Like, so it knows to build here, across here and here. So that's how you sort of like the basics of how like the surface are built together. So between here and here. So it's like you're trying to create this onto this. So this one you have this and you know this direction and this direction. So you need to create the same thing on this more fluid shape. When doing cross section on curves, are there amount of control point you, Jonathan? Cross section curves on surface, are there now? When doing cross section curves on surface. When you do cross section curves on the surface, you are directly taking the input from the cross section. So you section it, whatever is there is there. You don't have to worry about it because you are taking from the source. So you don't need to add more in order to be accurate. This is already what it should be. Yeah. And bit more general. How is manufacturing process and all things? Is there any available consumer 3D printer have the right property to print it? Okay, Diogo, you can actually print, well, I'm printing through resin, right? But you can actually print a wearable shoe with FDM. So you can look more into that. If I'm not sure if you guys are interested in 3D print, like being able to use a desktop printer to print your own shoe, like something like a course or something along these lines. Yeah, if you are, then maybe you can also feedback and maybe we could have something set up. So this is a resin printed one, which you need very specific means in order to realize that. But with like FDM, like extrusion based 3D printers, you can actually you can actually be able to print direct wearable shoes. You know, you have to tweak stuff here and there, but it's actually possible. And it would be cool probably after designing the shoe, you know, we can print and can do we can all share the progress of your own designs and you print them and share them would be quite interesting on like social media and everything. Sam, what kind of surface can be poly surface, mesh or NURBS? If I import a mesh surface from Maya, can I also use the same definition? Okay, if you import a mesh surface from Maya, you will have to, what you can do is take the mesh, do a quad remesh into, oh, you probably can still do something similar. You can, basically how this works is you create a surface. You create a surface from curves. So even if you have a mesh surface, as long as you can extract curves from it, the same way I do with this poly surface. Imagine this is a mesh. As long as you know how to extract these curves, these edge curves and cross-section curve, it will still work. It's based on the same logic. Yeah. How do you flatten the points when you divide the surface? Why do you flatten the points when you divide? Flatten the points when you divide the surface. How do you flatten the points? Sorry, Hala, do you mean maybe you can get back to me when you meant divide surface, is it dividing the surface in Grasshopper or dividing the surface in Rhino? Diogo, I use a like resin material that is somewhat like rubber, like it's like an elastic resin. Okay, the filament that you can use is, you can check out Filaflex. Filaflex from Spain, filament. I'll type in the chat. Like I think around 80A. Why do I in Grasshopper network surface? Okay. Hala, the reason why I divide the surface into points is because let me show you. This is the surface here. And can you see there's some discrepancy? There's a gap between the poly surface, the orange one, and the green one that I created, meaning that the network surface is not 100% accurate, like sticking close or not the exact, it's not exact to the trim poly surface. So in order to make it as close as possible, I divide the surface into points. You get these points, right? So you can see there's a big gap here and here. And then I find the closest points, which is basically similar to like projecting the points onto the right poly surface, to the poly surface end. Then I rebuild the surface. So your result, let me turn off. So you see this is before, so there's a gap still. You see there's a gap. And after, so this is no gaps, and it's almost identical to the poly surface that we are trying to, that the original input of the poly surface is. So I hope that helps, because basically we're just trying to get a more accurate surface in order to, basically it's just more accurate modeling. So when you use network surface, sometimes it's not as accurate. You could probably put more cross-section curves in order to get it more accurate. That's one solution. And the other solution is what I'm doing is to just get the point so that it can get as close to the poly surface. No, it's not just in your files, it's in everyone's. So I hope I explained it well and you understood. Diogo, if you want like 3D printed shoes, that's actually functional, you should go with FDM for now. Because I tried different resins, but it doesn't work unless you are using an industrial printer. Flex. 80, 82, 80. But what does flattening? Oh, you mean like flattening the points? Yeah, I think I maybe made that by mistake. It's already flattened when you divide the surface points. Yeah, so there's no difference. I just like turn it off. So yeah. Okay, let's continue. Hope you guys are back. Okay, maybe let me try a way that's easier, maybe easier to understand by doing it one by one. Sorry, like building it. So building it from scratch. So if you guys can skip to that bluish purple one on the net for the network surface. So everything you can turn it on, so everything we have up to the point of twisted box through surfaces is the same. So I won't repeat that. But what I want to do a little bit differently is, so as you know, this portion of the shoe is yeah. So this portion of the shoe isolate has a sole component, right? So it's gonna be in direct contact with the floor. So I want to be able to create a sort of like a traction pattern. So let me show you the pattern here. I want to add something like that. Let me take that out. So the first one is like that. Let me smooth this up. So the original one is something like that. So smooth and everything. But I wanted it to have a bit of like traction pattern. So I was trying to integrate that into the whole kind of piece itself. But instead of having the whole portion of the shoe in that pattern, I wanted to split it. So what you see here is sort of like a surface to cut. So I want this area to be in this pattern and this area to be in this area, sorry, the bottom layer to be in this pattern. So you have this additional like traction knob that comes up. So in order for that to work, the first and foremost important thing is to make sure that when you create the subdivision surface between the two patterns, it needs to match, right? If not, like they won't join. If it doesn't match, it won't join. What I meant is because the pattern is distributed in this way, right? This manner. So it needs to match. So let me move this to show you what I mean. So you see like the parts actually match and you can actually join them. So you can join them. So it has to match in order for it to work. If not, you have like two split disjointed meshes. So this is kind of like the important thing. And so if you turn this on up to twisted box through meshes using the purple blue group, you should be able to get this. And how do I do this is actually I surface trim box, which is also under Pufferfish. Under twisted box. Basically what you want to do is to cut the twisted box into two using a surface. Then you can apply like different regions with different patterns. Let me see. What is the name? Just the box. Trim. There's mesh trim. You can also trim it with mesh. You can, I think you can trim with mesh, either mesh or surface. But in this case, I'm using surface. So you have the twisted box already, which is this. So you connect that. And then you have this surface, right? So you input this surface, right click, set one surface, which is this. So when you click this, it will show you which section it's kept. Let me hide this. Let me hide this. Turn off preview. So after cutting, there's this region that's selected. So this effectively you cut the twisted box. So what you can do is with flip, you can select top or bottom half. So quite simple. And you want the top and bottom half, right, to fill. So and also, sorry, let me just explain this keep type with you. So 0 is completely keep if the twisted box is. Basically, you can read, it's just maybe how you divide the twisted box depending on where the surface is, which is not so important. So I will duplicate this because you have the top half, then you also want the bottom half, right? So this I'll flip to true. So top half, bottom half. And next you will want to morph twisted box off. Morph to twisted box. So let me turn this on. So for this, we want the previous one, which is the one that doesn't have the extra knob thing. Geometry. I will turn it into a simple mesh. So what's good about sub-D is that you can easily make it into a simple mesh. And after you do all your Grasshopper, after it goes through all the different components, you can take this simple mesh and you use a subdivision. You can make it smooth, and it will be close to what the toggling of the sub-D is. So, for example, what I meant is sub-D tools. So this is like the mesh, right? After you do a simple mesh, you'll be the same like that. But if you do a subdivision, subdivision, you can get it smooth again. So similar to what you get when it's smooth like that. So you get sort of like a similar result, which is good in keeping things light. So I'm going to use mesh for this, and then you need this as a reference. reference, and this is the geometry. Target would be the twisted box. So, and I can turn this to off. So you should be able to get, Oh, okay. Able to get this. Then let me duplicate this. And I want to use this instead, right? So let me connect to the targets first. The reference is the same for this box. So the pattern we want to change to this. And you'll be able to see this like this. Right, so you should be able to see this pattern that's like different from the top and bottom. I mean, these they are not like connected together, right? They are individual strips, so it looks like, doesn't make a difference. But if you were to flip the UV, so instead of like doing it horizontally, why if you do it like vertically, the pattern? Let me flip this to, then it needs to match up like that. So your points needs to, be able to your pattern needs to, that's why it's important for the what I explained just now, that this matches up with this, because in this case where it's kind of connected, you need to mesh and well. Weaverbird, let me use the Weaverbird. Join mesh and well. Into one mesh. Then I will do a subdivision. Sorry, cut. I'll do a subdivision of this to make it smooth. And after that, I'll offset mesh to give it a thickness. So this is like 1, which is fine. Both sides, no. Create solid, yes. Yeah, so this is a solid. I've got custom preview, so you can see, and maybe not in pink. Yeah, this way you can see the points coming together. So maybe we need to make it a bit smoother. Yeah, so you can get something like that. Looks a bit jagged here, so we will need to tweak the variable. So instead of maybe this one, we can have less 8. But in order to make it smooth, the reason why it's so rough, like so kind of jagged, because this way is not dividing enough. So it's, if you see the twisted box, it's kind of like divided into big sections, so it doesn't smooth out well. But if you increase it to, for example, 20, it becomes smooth. So you get this, and also you get more spikes here. Like, sorry, the texture. Also, what you can do on the fly using this is that you can, so the edges have to be kept the same. This area, so that everything kind of still joins, but you can tweak here. For example, here, and you'll be reflected onto the pattern. So for example, I'm gonna widen it. So this is also widen, you see. And if I kind of make it like smaller, less extruded, you'll also be reflected here. Yeah. So I think that's sort of like the 2 ways you can play with that. There's 5 of them, and if you turn them all on, you should be able to get. Let me try to turn them all on. Anyway, let me fix that later. Yeah, if you guys can try to turn it on. Enable all of them, because they are just repeated, just with a different starting curve and the surface to be mapped into that. You should get something like that. You should have 1, 2, 3, 4, 1, 2, 3, 4, 5 pieces. Weird. Yeah, you're supposed to get 5 pieces from this. You should be able to get something like that if you turn them all on. You can tweak and play with the different variables, like how much do you want to divide the pattern, like how much pattern between like kind of like the U and V, UV, and then you can also play with replacing this pattern with something that you want to tweak with, or you can, change them up. What else? Any questions so far? Hala, Hala, you need to go. I think you'll be able to get a recording through email. I think Design Morphine will be sending you an email where there's a link for you to access the recording. Okay. What problem is this? Weird. Anyway, let's continue. Do you guys need a break? Maybe a shorter break, 10 minutes break, or do you need a 10 minutes break, or you guys are okay to continue? And let me know in the chat. The next part that I will do after this is to create pattern. This section here, upper pattern here, I'll go through. Basically, it's to create pattern over on the upper here, but with like a few different variation or strategies to do it. Right. Yes. Okay. Can you show us something about the internal modeling part? Maybe let's go. Maybe let's go for 10-minute break. Ten-minute break. I need to charge my earphones a little bit, and we can talk again 1:06. Okay, cool. Okay, shall we start? Okay, let me build. So the first, so now we are kind of looking into like the pattern for the upper. The way I do it is that I will use the, like for the design, I'll use the pattern to cover the whole area instead of just like the last area. So I built this previously. I showed you this part. So I kind of cut out the collar space, and we'll use this whole. Let me hide. Let me hide this mesh. You use this whole area to generate the pattern. So the first one is minimal spacing tree. So for the patterns here, I'll be mostly using Parakeet. Where is it? Oh yeah, here. Parakeet. And I'm using a few options. So they are, I'll be using minimum spacing tree, maze. You can. I'm also will be explaining flow path, venation 1, venation 2. But basically, venation is kind of like network that resembles roots or resembles leaf veins. So I'll start with minimal spacing tree. So we just put it here. Script. So in order for minimal spacing tree to work, you need base points. Sorry, let me just turn this off. So you need base points. So how it works is that, so we have this geometry already this is in upper in Grasshopper. So let's add that in, set one geometry. And then you need points, right? So you can populate geometry. So basically what it does is that it creates points on this geometry. It's quite literally that. And maybe we can bump the count up to 1100. Put the points in. You should be able to get this pattern. Let me just turn this off so you can see. Pretty cool pattern. So you can see that there's this pattern here. So basically, minimal spacing tree, what it does is it creates basically a network path that is possible with the minimum total edge length. So this kind of resembles sort of like a I guess tree branch. So this is pretty cool. So what we need to do next is we can use tool called Homogen from Intralattice. Let me see where sorry, this is like my screen is too, it's not wide enough. Let's see it.
Hey Shun,
Yeah.
your screen is off.
Oh, apologies. Yeah, sorry. I'll just like repeat that real quick. Right, so we'll kind of start with this geometry. So we actually have it under the Grasshopper in the upper layer. So this layer, you can like put that in geometry, and we are going to use the minimum spacing tree. So this is under Parakeet. So we're going to generate pattern from here. So as you can see, few of them are like the minimum spacing tree, Venation 2, flow path. So I'll be using a few to kind of generate pattern. It's useful for that. So with that, so firstly, starting with minimum spacing tree. So we need basically it needs the points around the geometry. So we need to generate that. So we use populate geometry. So basically it populates points. And then I set it to 1,100. And then we just input that
Hey,
in.
your screen is like chopped off.
Chopped off?
Yeah, it's like sharing half of Grasshopper.
Yeah,
Maybe
it's
unshare and reshare.
okay. Oh, okay.
There
You
you
got
go.
it now?
Yeah, yeah.
Okay. Sorry about that. Yeah. So you didn't see what was going on, but basically it's generating the points here. Then after that, I connected it to like minimum spacing 3s, and that will create like the shortest path. Shortest path connecting all the points, and you sort of get this tree-like structure here. Turn on the curves. Well, so you get this pattern. Then next, I want to create the thickness, right? So in this case, I'm using Homogen from Intralattice. Here, here. So with this, maybe I can set a radius to 0.7. So you sort of get this pattern, but when you turn on, then I am turning on this upper layer under armies in Rhino. So you can see that some of the points are not touching, sort of like disappearing. So what we need to do to fix them is, firstly, the points are not, because there's a thickness here, right? So the original upper is somewhere in the middle, and it's offset to create this surface, this solid skin mesh. So it needs a bit of offset to raise the lines to be on the surface of this mesh. So in order to do that, we have to offset this. So instead of offsetting poly surface, I'm using offset mesh because it's faster. So I first need to change this to mesh. So I'll mesh this. So I'm not gonna have solid, so I'm gonna keep it the same. And then I'm gonna plug that in. To a custom preview. Right, so you can see the structure is growing just over the curve, the surface. And then so that's that. So this is quite straightforward and simple. So I think now you don't really see an issue with that, but in reality, these curves are like straight, and the mesh is actually has a more has a bigger curvature, meaning like these are polylines, so just straight lines, but this mesh upper has more like curvature that's like continually moving, but it's just straight line. So there are some times where the pattern will get overlap from the curvature of the surface of the mesh. In this case, it's not so obvious. Maybe the next one when it's more obvious, and I'll show the solution for that. So this is one solution, one way of creating pattern, which is quite simple. So I'll just show you a few like strategies to do that. Next, we can try Venation, the one in pink. Venation 1. Using Parakeet, pattern generation, Venation 1. So let me open 1 and 2. It's interesting to see what's the difference. So Venation 1 and 2, they are quite interesting because there are certain differences. So this one is taking a root indices for basically it's sort of like a root or vein-like structure that grows, but instead of this is taking the indices. So like in terms of like the number, like the points in a list, it takes the indices, and this one takes the root points. So this is actually a actual point, and this is just a list number. So let's start with the first one. Let's see if we can use the same input. Venation points, let's use the same points. So the root indices is you can pick any one from like from 0 to 1099, because that's the least length. You can pick any of the dots as a, sorry, the points as a starting point, as a start. So I'll just choose one. So now you still don't see anything. Branch count means maximum number of branches they can come up with. So I think 3 is okay. You can tweak it if you want later. But I think cutoff distance is the one that limits is the reason why this is not showing up, because the cutoff distance is too short, meaning it doesn't really have chance to like grow. So let's set a higher number and try. A bit higher. Right, so you can see the pattern that's being generated. So it says indices, now it's just one. You can also add a few, so you can add maybe 10, 20. I will certainly. So now instead of a singular starting point, it will have a few. So that causes the shape to change. But let's check where are the points from. So let me list item. So this is what it meant by taking the index. So these are the actual points where it starts to grow from. 1, 2, 3 here. So that's one way. So in this manner, you kind of have less control of how you want to place the point. Means you gotta, for example, if you want the point to start from, for example, the tip of the toe, you have to, keep sliding the slider until you get close to that. So if you want something more specific, in this case here, I have a point here that I want to insert. I can do this. At this point, point doesn't work, because I need to select. Okay, I use it as a geometry. And what I can do is I can merge So you add this point into the collection of points and you flatten them so that it's one collective collection of points. Then you can remember under list item index. So this point is here, and this is the merge one, including that. Add that into the list, and this is the item, and you have the item index. The item index is 0 in this case, and you can use it as an input for the root index. So this is like the starting point here now. So likewise, if you want to create a thickness for this, you'll be able to have this. Oops, quite similar, this and this. So another way to make it more interesting is you take the same number of points, keep the same points, but you generate it twice using this minimal spacing tree, and also taking this venation one, because the points are the same. So the kind of, I guess, the generated pattern collides well together. So you get something like that. And let's just try seeing it visually with turning the pattern, turning the pufferfish structure on. Like that. There'll be something like that. I mean, the volume is not filled yet, so that's why it looks like that, like empty here. But basically, you'll get something like that. Of course, for this, you can make the pattern more dense, and you look better, and you can make it thinner. This is quite thick now. You can make it thinner. Let me try that. Hopefully it doesn't take up a really long time, because this minimum spacing tree can take some time to generate, some depending on how many points, and this homogen to create the thickness of the lattice can also take some time. So I try not to go so high for now, but let's see the effect. So it's when it's just one pattern, using it on its own usually it's not as interesting as when you are able to generate a few and combine them. So sometimes I do a combination, maybe using the same the exact same points, and they sort of like collide together and kind of create interesting effect. Like that. So I think this is I think a more like richer design. Yeah, something like that. So okay, maybe I can answer some question. The homogen in your file creates separate cylinder, not a single continuous branch. Let me check. Shouldn't be the case. Maybe you can try following my instructions and try to recreate the pattern to see if it happens again. Can you show us a way to change the density in specific areas? Yes, I can show you how to change the density in specific areas for this pattern, right? Yeah, let me see if I can show you how to make it variable intensity. For example, let's see how can I do it. Okay, to make variable density, you can, let's take the same point and let's move the points closer. So these are the previous points, right? So with these points, what I can do is I'll take these points and I will move them, let's say closer to this point where I used it previously so we can reuse. So first, let's try to get the distance between this point and the rest. So, which means that the higher the closer the closer it is, the more it will move towards the point, right? And the further it is, the less affected it will be. So which means the smaller amount of points will move it closer. So in order to do that, I will get distance, and I can do vector. Vector is just so that I'm doing a vector 2 points, just so that you know which direction it's gonna move in. So you don't actually need the distance anymore since you have the length. Length is basically the distance, it's the same. So with this, you can so basically what happens is it's drawing this line. To kind of calculate the distance, right? So we want it to move closer towards the point where it's the closest, and we will. But obviously, we cannot move. If we are using this exact vector, you move exactly towards this point. So what we need to do is to reduce this number. Let me see. Vector amplitude. Let's try something simple. See if it works. Remap. Remap number. So the source is the bounds. So remap number is basically the length is sort of like the information we have about how much it should move, right? So what I'm trying to do is to remap the number so that it just doesn't move exactly to, not because the length is like, for example, somewhere that's far, this is like maybe 20 or maybe 20 or something. But if I were to put exactly into that as an input, it will just move towards the point. So there's no point. Everything will converge to this spot. So let's make it a range of number. Maybe it should move maximum 5 or 2 to 5, for example, or 5 to 0. So let's set something like that. So let's get the number set. Domain. I'm doing it from 5 to 0. Start and end 5 to 0 because the closer it is, technically the more it should move, but the distance is actually shorter. So by flipping the domain, I'll be able to kind of flip it the other way around. Means the closer it is, you'll move closer to it, the further away it is, you'll move further away from it. Okay. Let's make it unitize, means the vector will only move a total of in XYZ, you will only move a total of 1 mm basically. Then we can use this to do a amplitude to magnify the vector. So ours is 0 to 5. Let's hope it works. Maybe it's not enough. See if I can make it move more. Nice call. Let me check it. Nice. You can start to see it moving together. Let me change this. So it's moving further away from this point. And then you have the points here. And you can plug that in. Yeah, it's not so obvious in this one. Maybe I can update you guys with another another script that would more effectively show how to make it denser, since we are in a bit of a rush for time. So not really rush for time, but yeah, so I can cover other topics as well. Maybe I can do a separate script for that. Yes, with attractor point, you can use attractor point. You can use attractor point. You can also use you can populate more points in a certain area that will work also. Let me get back to you guys with a better, more effective solution for this. And let me see what's next. Yeah, another method for creating something similar, having different density of points around the geometry, but in a less controlled way, is by reducing mesh. So for example, we have this populate. So instead of populating geometry, let's do a try remesh. Okay. Let's make the target length about 3. So what this does is it remesh the geometry into, you know, triangle mesh, and it has a length of about 3. Let me turn off the rest. You can see. And what you can do next is reduce mesh. So we reduce the number of mesh to, now there is how many faces? About 18,000. Let's reduce it to about 2,000. Sorry, a little bit less. So this is the reduced mesh. As you can see, it's maybe a little bit more. It's a little bit more organic, and in certain areas where there's more, so in certain areas where there's more curvature, the mesh will be denser. So you sort of get a sort of like variation of density in that sense. And then you can also use this as a input for, I was using it for animation 1. First deconstruct mesh. Deconstruct mesh to get the points. And then with these points, a little bit more irregular. So if you see here, I think these areas are flatter. So there's less points that kind of congregate because you don't need so much there's less curvature, so it doesn't need so much it's less dense basically on the mesh surface here as well. So there's a bit of variation. So yeah, you can see there's a little bit of like variation. You see like there's like gaps here, and the rest a little bit more dense here because these areas are probably like flatter. So these are like what you can also play with. Yeah. You see the question. Can you share that script? Yeah, whatever I'm doing, wait, let me Jonathan, when can you combine them? Do you do a Boolean or something? Oh no, I don't Boolean them. I usually just leave it as it is. Because when like I mean you can do that, but it would take more effort than required because I could just print them like that, like with all the overlapping kind of parts together. It's fine for 3D printing. But if you do want to do that, you can actually do that in Dendro. Walter, like the script, I'll update the script and I'll update and send you guys again. I'll try to tidy up because it's kind of messy right now. Then as for Patrick, they are not like the shoes and EPU tile or EVA foam like material. They are not. I don't think they feel like either of them. If anything, it's closer to EPU, but it's the material has more I guess like bounce to it, so you can feel the spring back more. It's maybe similar. If you try Adidas 4D, it would be something closer to that, or maybe a Ultra Boost, maybe something like that, but that's in TPU. So yeah. Shore hardness is I'm using I believe it's 85A, 80 or 85A. Yeah, I think in terms of like characteristic of the material, it should be around a hardness of about 70 to 80A range for it to work well for footwear. Otherwise, it might be too hard or maybe too soft. And the shoe might be too heavy or might be too heavy, it's too soft, if it's too soft. Okay. So next is Venation 2. Okay, so there are some parts where I divide the curve. divided the curve and then projected to the to this upper. Reason is because, for example, this one, maybe it's good that I show a little bit of this. If you look at the blue one, just want to show you a bit of the rationale for doing that. Because the curves are straight and the poly surface is actually curved, right? So there are parts where, you know, if it's straight, there will be like gaps in between, so it doesn't follow so closely. But if you, so you'll be like, you know, floating. Oops. So the point to rebuild it so that it gets closer to the surface. Sorry, what you're seeing now is coming off because it's offset. Let me turn on the offset. So it's, you know, going closer. If not, it would. Let me show. Yeah, it's kind of minute difference in this case, not as obvious. But sometimes, if you have a more like curvy surface, that might be more obvious. Let me turn this off. For example, this one is just a really small difference. Can you see? So this is the original one. It's just a straight line, right? But you do realize that this horseshoe upper is curved. So, you know, when you rebuild it, so what I do is I take the original curve, I divide them, and then I find the closest point. So you know, one poly curve, I'll divide it into 7 points. Sorry, it's 7 plus 1, so it's 8 points here, and it's gonna be on the poly surface itself. Then after that, I will create a curve based on that. Then this way you get the curve to match the poly surface exactly. Yeah, so this is just one small detail that you might kind of, when you create the pattern, you might kind of want to take note. Okay. Next is maybe stagnation point. animation tool. So with this, also same thing, points, but now we need a mesh, which we already have because we did a remesh here. So you can also with this mesh you can deconstruct mesh. So list. So this is this point, we're gonna use it as the main base point. Sorry, my bad. This should be here, all the points here, and the root points is where it starts to create the root. So we already have one point that we are using just now, which is this one here, and we can reuse it. Or any points on the poly surface itself we can use. I think this one will take a little bit of time. I think this might take a while to load. Maybe we can have a 10-minute break. 10-minute break, and let's come back at 26. We can come back in 26 and I can show you how to do this second one. Thanks. Yeah, I will. We can extend a bit of time in order to cover KeyShot and Photoshop. So it should be good. Hi, thanks for waiting. Yep. So looking at the pattern, for Venation pattern 2, this is what I did. So it needs like a few inputs. So the point, this is like the overall number of points, and the base mesh is basically the poly surface itself. You could just mesh it and use it as an input. Then root point is basically where the point where it kind of branches out and grows. Cutoff distance is where maximum distance where it explores a new branch. So let me just hide this. Yeah, you have to be a little bit careful with this Venation tool because it takes quite some time to load. So I'm not gonna put too high a number. So I started with 100. Maybe I can do like 500 next. Yeah, try not to. I think of course you want a more detailed kind of pattern or structure to play with. Just take note that it would take some time to generate this. So I tried with 100 and now this is 500. Hopefully give it a minute. And after this, I think I'll just start to get into like the lattice midsole. I think there's extra 2 designs. I think you can like turn that on and check that out. They're using a similar logic as what I have in the earlier example, just mainly changing the main component is changed, but most of the other components are still relatively the same. So with this, let's see, all is good. Okay, so with this, you can see sort of like the Venation pattern. So this is very different from the one earlier. For example, Venation 1. Venation 1 is like it's a complete different kind of pattern. So this is more of, I think, more evenly distributed. And I think the way they are, I think program is quite different. So I think it's a variation of the design. So this is really more like a leaf. And if you, let me just, because it's gonna take a long time if I keep doing 500, it's 200 and try to illustrate the difference. If you tweak the cutoff distance, for example, let's do 0.5. I think that's the maximum distance you explore to create a new branch, and then step size is how big it grows. I think this is sort of like the step size. Let's try something bigger. See what happens. Yeah, it sort of like changes. I think it is less I think it's more regular. It looks straighter when it's a bigger number because like the steps are bigger between all this. So this, I think it's easy to tell if you put a discontinuity. So I think this is 0.5. Previously was 0.2. Yeah, so like it's mainly this difference. Yeah, I think this particular pattern can be quite interesting, especially if you were
Ping, your audio isn't working. Ping. Hello. Ping.
Me now?
Hello?
Yeah, sorry, I think like my AirPod was maybe
Yeah,
off.
it was dead, yeah.
Yeah, sorry. Yeah. Anyway,
Maybe go back like 5 minutes.
yeah, I was saying with like the Crystallon, I was trying to do this so it's good for creating lattice for midsole or in general kind of generating lattice structure. And with that, this particular one creates a Voronoi fill. So Voronoi fill, Voronoi is a, how can I explain? Sort of like a pattern that you can see in nature where, you see, when you have a sort of like a cup of bubbles where, the bubbles kind of come together and it creates sort of like that structure. So that is what it is. And this is like the input that's needed. So you need the main geometry to fill in with, and then the number of points. You can use attractors if you want to. And then after that, you just enable it with a toggle. So you get something like that. Switch on. So initially you'll be getting this. So you get a skin component. Skin component is the kind of outer shell lattice. Then after that, because like everything it has the skin and it has the overall like Voronoi lattice, so you don't really know which one, as in you don't have the, just the midsole itself, so you need to trim it. So you trim it separately here to get the inside. So basically it's Crystallon trim lattice, so you can use a geometry, can be a B-rep or mesh. So we use the input that we have, and then you take this lattice and you trim it, and the result will be this. Like there's trim and untrimmed lattice. So let me show you what is it. Basically, you need both, but what it means that trim lattice is the one that's actually trimmed, and untrimmed lattice is the one that's inside, but the line is not trimmed at all. But you need both. So you take both and you combine it with the skin, and that's where you can get the completed. Oops. That's why you get the full lattice with the like the outer shell as well. Yeah. So you get this lattice. And this is Dendro, which it creates the volume from the curve, from curve to volume. But let me explain this a bit later after I try change it to Windows OS. But now I'll just explain how to create like different types of lattice lines. So one thing that they have is using attractors. So they will attract like to have denser points, but I usually don't use this. Personally, what I do use is getting because like if it's just points, if you put points inside, you strengthen, you kind of make it dense in one area, like it's like congregated into towards one point. But for example, if you were to wear a shoe and you step on it, the pressure point would be more of an area than a point. So with this, what I usually would do is I would cut a portion of this midsole and use it as a input instead. So what I'll do is I'll get the points. Maybe this one I can go through it later so it's easier to understand. But essentially what I'm trying to do here is taking the points and I'm checking whether these points. So first I divide these lines into points and then I check if they are inside this BWrap, this poly surface, because this is where I want to strengthen. So I check like, so these are the points that are inside. So what I'll do is then do a variable thickness. So I'll do a variable thickness between this and the outside. So this area would be thicker than the outside. So that's one way to make variable hardness in this one material. So basically what I'll do is to map the numbers. The parts that are inside will be 1.0 and the parts that's outside will from here onwards slowly go out, freeze out to 0.5. And another way that I do it is so there's using Crystallon to generate this is a more like automated process because I think this is mainly scripted already, but you can also do it more manually where you can actually have more controls over in some areas. So what I do is using Voronoi 3D. So this is actually already inbuilt into I think native into Grasshopper that you can use Voronoi 3D, which is this one. So what you can do is let me just run it a little bit. So with Voronoi 3D, you need to populate it in a, usually it populates in a box. So what I'll usually start with is a bounding box with the midsole inside. So basically it's the bounding. What it does is that it creates the box volume for the midsole. Then I'll populate 3D. So I'll just populate points as the base for the Voronoi. And after that, I'll create the Voronoi 3D. And use, because you need a box input also, so that's where the bounding box comes in helpful. Yeah, usually I will, just as a precaution, I'll clean so as to remove any like null or like invalid cells. Then I'll take all these cells and I'll deconstruct it into edges. So they're all edges. Let me show you here. So just basically the lines and curves. And then I'll trim it with the midsole geometry. So basically it's the same thing here, and and this is intersecting. This is getting the, remember, like we had previously, we had this trim geometry, but we also need to get the shell. If not, it's just like it's all floating, so it needs to connect together. So what I'll do is I take this intersect B wrap and B wrap. So this is a B wrap and intersecting with the main shape here. The result of the intersect will give you sort of like that shell lattice that I showed earlier. So this is more of a manual way to do it. So you get this and this, so it's the same. But what is useful about this is that you can actually create a variable density this way. Previously with this, I can only, like the previous example, I do variable thickness, but with this way I can customize the points. So I can do a certain area whereby it is denser. Yeah. Yeah, sorry, Alex, you were asking, right? So yeah, this is what I meant. You can make it denser, so variable density. So enable this. Okay. So with this, what you can do is, so this is pretty much the same as previous, but what I do is that I took that region just now, this region, and I populated. So I did the exact same thing and check if it's so I populate 3D, which is it populates within a box space, and then I had to check for whether it is inside, and after that I use it to combine with the overall, so you can have really specific dense areas where it's denser. Same thing, can't really see here. So up to here is the same. And if you see this trimmed, so it's all up the same. It's just basically this area, instead, I did one more exact one, and just populating this area with the geometry, with this cutout portion of the midsole, and then I kind of added it to the whole point collection for the overall midsole, and then the result is that you get a more denser area here. Not sure if you can see. I think you should be able to see, right? So this area is denser than the rest. Hope that kind of answer your question. And all these are Dendro, which I can show afterwards. So another thing that you can do that's also more interesting, using the same logic, but you have it in a more organized direction, like a more organized point system. Because you see so far the points system, the points are kind of distributed in a random way. So your lattice are like super random. So using kind of like the same logic to make a more organized kind of form. Yeah, so let me enable this. Yeah, please hold on for a while. I think usually this is heavier.
Okay. Can you guys hear me? Just to be sure. Okay, cool. Yeah, I'll keep track of the chat in case you cannot hear me. But let me share screen. Okay, so this is, I call it custom for Noi, or you can call it whatever you want. But okay, so for this, what I'm trying to do is to create a more organized way of creating the lattice. So with this, I'm going to make voxels. So voxels are individual units of, basically they are similar to twisted box, but what they are is like boxed, like many boxes stacked together, and you can put in different lattice unit cell to kind of create the whole midsole. So let me preview this for you first. So basically, you'll get sort of like this kind of volume where the midsole is actually filling the midsole, like so. So the midsole is inside here. You could, you can almost see that. So I start by creating a bounding box, which is, this exterior box. Oh, sorry, not this one. This one. Create a bounding box. Turn this off. Sorry. Creating a bounding box. And then in order to, so basically what I am trying to do is taking this box and I'm trying to divide into the exact same cube size. So I'm trying to get a cube out of it, right? So if not, your lattice will be of like irregular, non-uniform size, which is not what you need, not what you want, because that would make the lattice less functional because they are not isometric. I think isometric is the word to use. So we need to create like the individual voxels as close to a cube as possible. So we keep the lattice constraint in it in a cube basically. So in order to do that, we divide it. So basically my aim is to create individual cubes, voxel cubes with 20 millimeters length, breadth, height, right? Because it's a cube. So what I do first is I take this box, I take the box properties, taking the diagonal. So if you deconstruct it, you'll get the basically the length, width, and height. So this is the length, width, and height. And I divided all of them by 20. So the first one is 114, 100, 291, and 78 respectively. So I divided by 20. So the result is like 514.5 14.59 and 3.914. But the thing is, you can't divide this space, you can't divide it into individual by decimal points. So I have to round the number up. So when I divide it into individual voxels, the voxels will be whole, right? So by rounding up to the nearest number, so 6, 15, and 4, into this voxel by volume, so by the geometry. So basically I take the geometry, which is the bounding box itself, and then it needs the parameter. So same thing with parameter, it's 0 to 1. So we need to divide them into it needs to be increment of 0 to 1. So what I did was to place them in range, and the range it's always 0 to 1, like as a default. So you don't need to input that again. So the number of steps will be, respectively divided by 6, divided by 15 steps and 4 steps. So the result is this voxel shape. So that's sort of like the basis for everything. So next, I try to fill it up with, I fill the space with cells. So with Crystallon, what you can do is you can actually choose the cell. So, and you can actually preview them. Let me show you. So you can pick from here. So this is cell selector. So you can select the cell and connect it to the cell type, and that becomes the unit cell. But basically, there's quite a lot of option or variation. So I'm selecting one here that's a bit more simple. So like a cube one, and then there's a lot of variation you can try, which makes this interesting because with this alone, you can have a lot of different variation of the lattice structure. Yeah, hold on a moment. So yeah, so it could be something like that. So when you actually fill it up, it looks like this. So instead of using this as it is and trim it with the midsole shape to get the lattice exactly like that, what I'm doing is something different. Is I'm taking the points, so they are more kind of like varied points like that, but in a very organized way. And then I'm gonna do a Voronoi, 3D Voronoi. Next is what I do next is exactly what I did from previous example, is really taking it and trimming it and getting the intersecting curve or intersecting lines. And the result will be this. So what's interesting or helpful about this as compared to, I think the main difference, if for example first of all, of course, it's not the same pattern, because the input is we are creating a Voronoi. Voronoi here using the points instead of using the curves like this, the individual unit cells. The reason being is that if you trim this cell, unit cell, you'll get a kind of raw cut with the edges kind of pointing outwards, and there's no shell. So basically what you'll get is this. So that's kind of, to me, that's kind of like a disadvantage. So basically you'll get something like that. You only get something like that. So the edges will be hanging out in like, just like naked. So to me, it's not so ideal. That's why I thought that this way you could get sort of like a shell on the outside, and the lattice structure is a lot more uniformed. And with this, you can also try variation in form. So for example, if you just do a simple cube, you end up with this. And if you change it to a more complex shape, for example, this. So you can actually play with the density, not density. You can actually play with the different types of unit cell, and you can see which works the best, and you can tweak in terms of thickness. So there's a lot of parameters that you can play with. Sorry, let me check. Hi, Ara. It says while the object is remove duplicate points for plug-in kangaroo component. Maybe you can try. You should be able to find a similar one in Pufferfish bar, I believe. So anyway, let me just show this to you real quick. Do you think you can, Ara, do you think you can delete that component and maybe replace it with let me see if I can find Ara, for mine, I think nothing shows up. I think it's working properly. So I'm not sure if it's your Rhino version.
It means Ara doesn't have that kangaroo installed.
Right.
You have to go to Food for Rhino, install that kangaroo.
Right. Jonathan and Ara. Okay. So if that's the case, maybe what you can do is maybe try to download instead of Kangaroo. Have you tried downloading just Kangaroo? or both have the same issue?
So Kangaroo 2 comes with Grasshopper. You should install Kangaroo 0. Whatever 99 to have those extra components. You can have both Kangaroos. They're different.
Right. So maybe
Just 2 comes installed. You need to install the other one. They need to install the other one.
right, the regular Kangaroo.
Yeah. So just if you have error, just go to Food for Rhino and install that Kangaroo version.
Okay, cool. Yeah, but basically, this kind of sums up the lattice, midsole lattice. And now I will, so you guys can try adding different, like in the unit cell selector, you can like try different ones, except for the shells. The shells are not supposed to work in here because they are supposed to be like lattice, so not shell. So you could try this, and next I will just take a really quick 5 minutes just to turn on the window so I can show you how Dendro works. And after that, we will be able to do the KeyShot render. Hi. Let me know if you can hear me.
Yeah, all good.
Okay, okay, cool. Yeah, so this is the result of Dendro. So as you can see, like really nice.
There's nothing
And
sharing.
oh, yes. Yeah, okay. So you can see now, maybe. So yeah, now it's with Dendro. So continuing the same orange color one that we're going through. So after you merge, you get all the curves. And with that, what I usually do is I will use this component called points to volume. So with Dendro, there's a few different settings. So there's curve to volume, points to volume, and volume to mesh. So we will need, in this case, volume to mesh, and either curve or points to volume. But in this case, I'm using points. So what Dendro does is that it creates a intermediary kind of form. I guess it's called volume. Then after that, they'll convert it to mesh. So I think they did it in such a way that it's to optimize the generation of that before kind of converting to mesh, because I think mesh would probably be more heavy to kind of generate. So what I do, the way it is done is that I will take the curves, I'll take the curves and divide them by quite a small amount, 0.35. And with this setting, you need to create a setting for the point to volume, or essentially you need setting for everything. So you just use the same one setting for all. So this is what I do. Of course, you can tweak in variation of the voxel size and everything. And what I find what works best is this setting for it to work. For this, I think you can maybe use this as a guideline, because it's quite difficult to tweak sometimes, because how can I explain? Because these are kind of like relative like numbers, and also like we don't really know, it's more challenging to tweak because you don't exactly see what it changes other than the fact of whether it works or doesn't work. So in this case, I think maybe taking this as something that you can use consistently to come up with success generation of Dendro would help. So without going too much into this, you take this setting with these two plugin 0.35 and 0.004. For me, has the higher success rate of generating than the mesh without problem. So after dividing length, you could do this. And another way you could do is by taking just the curves. For example, same radius, and you just take the same setting. So you see sometimes it doesn't work. So that's why Dendro can be tricky sometimes. So that's why I usually don't use curve, because they give me more problems and it's quite hard to identify the problem. So That's why I would recommend you to use divide by length, and you create points and you use 0.35 as the input length. And then you can create the volume. So this is the you input the points and you put the radius of what you want. So in this case, it's 0.1, but it could go smaller or it could go bigger. And the volume setting will apply for all. So you're using this once, and after that, volume to mesh, you also use the same setting. And after that, it's just changing the volume to mesh. And usually I would use this. So this is a script. The plus, see if I can show to you. But basically what it does is that there are some times where Dendro fails, so you get like invalid mesh, and that's quite frustrating. So what this does is oh no, okay. So this runs a simple script if the mesh is invalid. Let me see if I can make it bigger. If the mesh is valid, it will check for it will combine identical vertices, and it will also count degenerate faces, and usually this would actually help resolve the issues with Dendro, because sometimes when you generate the mesh, it comes out successfully in volume without problem, but when you get it in mesh, it has it shows that it's invalid. And a lot of times the reason is because there's when you trim the lattice, there's like sometimes like tight tolerances, or the gap between the points or the lattice are really short. I think that creates some degenerate faces or really close points. So this helps, and usually I would check the mesh for volume if the mesh is valid, and yeah, I'll check the volume to make sure everything's okay. Sometimes the volume can be negative, so in this case you need to flip the mesh. But other than that, I think it's good. So I think in general, like with Dendro, especially when using lattice, you can just use this almost like a formula, because that's usually how I use it. So to be sure that everything comes out properly. Yeah, and you can apply it to everything here. Everything else that as a lattice, like the ones that has midsole, all of them you can utilize this. Yeah, and with this, thing is done for the 3D modeling portion. Then I'll go into I'll try to make it quick with like KeyShot and Photoshop. So let me turn those off and start KeyShot, and let you guys know when I start it.
We don't hear you again.
Hey Alex, let me show you how to do it later after going through the KeyShot in Photoshop. Okay, so this is in KeyShot. So typically this environment is like the default one, but usually what I would use is something along the lines of I would use something like a simpler lighting with you can have like studio lighting and all, but like what I would use is a more directional lighting like from the sun. So you could say this HDRI from the sun, I think it's default from KeyShot, which is quite good. So what it does is that it creates a lot of contrast and a lot of like depth to your model. So it's easy to, I think it's sort of like an easier way to get a nice render. So I have a material that's like a basic glass, like a solid glass material, kind of set it to like a dark one. Reason being, why I use glass is because this material that I'm printing with is sort of translucent, has a little bit of translucency. So I'm using this glass with a high roughness index, so it's somewhat close, and its transparency distance of very small, 0.1. And also what I would like to also add is a theme, like a ground plane, so as to accentuate the model. Usually I would add that. If not in KeyShot, I'll do that like post processing. So what this does is in general just make the render more convincing and natural. So let me check camera angle. So usually what I would do is to get I think with render and lighting, it's a lot of experimentation, but I think a kind of rule of thumb is like what you would want to showcase in your render. So in this case, I think what stands out in my render is this like pufferfish pattern that we did, right? So I would find a lighting that kind of accentuates that. So maybe something like that could kind of highlight. You can see like on the rounded areas of the pattern, you can see sort of like a streak of light on, or like a highlight on them. So something like that would help. And of course, what with render, having like a pair would definitely help as well. If you're doing footwear, a pair would definitely help. And also for example, if you can model feet, sorry, legs, would also be more convincing render for sure. Yeah, something on feet. This is not the exact same design, but you know, it's just the logic of how you do it. Is there anything specific that you guys want to know about when it comes to rendering or KeyShot? Thanks. Yeah, so something like a render like that, I think would be already pretty useful as or convincing as a concept render. And yeah, and usually like strong shadows will also help the design pop as well. So it really depends, because like with rendering it's quite varied, so it really depends on the effect that you want to achieve. And lighting is really important, and maybe you could consider what you want to showcase on the design before you render, and then find appropriate lighting to match that. So with this, I have also came up with two rendering similar in this similar lighting setup, and maybe I can do the Photoshop and I can explain a bit about the Photoshop process. Let me know if you have any questions for the KeyShot. Let me just turn on Photoshop. Oh yes, sorry, one more thing about KeyShot that's important is that when you render, how do you make the final mesh to KeyShot? Okay, when you render, I think one most important thing is to tick this clown pass. So what this does is that it separates the object by like a kind of like color image, where you can easily select the different parts of the render to do post-processing after that. So remember to check this. Mason, currently I don't take the render from KeyShot to me. Actually, I did try it, but I didn't have so much success yet. I'm still trying to figure out how to realize that, like almost like taking as an iteration of the design. Like it's sort of like a loop, right? So you can sort of like feed it back to MidJourney, and you can, have a continuous output from there, which is quite interesting, I feel. Let me just share the. Oh, you can definitely do that, Mason. You could just throw it in into MidJourney for sure. I mean, it's like what I showed you earlier, where you throw in the image, after that you copy the link and use that link as an input to MidJourney, and you can generate images. So I'm guessing you just wanna use that as a image to maybe splice things together, or create new designs from your original designs. You can actually do it now. It's just that I didn't have that much success for myself in creating nice or good design. But it could have nothing to do with your experience. It's just my personal experience so far. So this is the. Okay, let me share screen first. Okay, Photoshop. So this is the clown path I was talking about. So what's useful about this is that you can use magic wand, you can select. You might already know that. I'm not sure if you guys already are using this. And you can just specify this area to kind of, adjust. So I adjust the levels a little bit and use curves. So the reason why I'm doing that is that some portions are really dark and you cannot see the details. So I'm trying to do it so that it's easier to see the details, but still have contrast. Also, what I find helpful sometimes to make it a little bit more convincing is almost to create a accentuate the light direction. So for example, the shadow is kind of pointed towards the back, so obviously the light is from the front. So what I'll do is I would take this using the color path. I would use the magic wand, select. After that, I'll do a levels and I'll darken it, and then I'll use gradient tool to kind of lighten the front to the back. So you can see sort of like a gradation slowly, and you mix the light. You can sort of feel the light more, just a little bit, not too much, to kind of help accentuate that effect. And also same thing for the background. So you see sort of like a light direction, brightness. Yeah. And overall, one more thing I would do to make the image more cohesive and kind of have a movie effect is to add a camera filter. So let me it has like the layers have to be compressed in order for it to work or be in a smart object. So what I'll do is I'll merge these layers. I'll just keep this as a backup in the folder, and I'll make this into a smart object. So what I'll use this to do is I would filter. I'll use camera raw filter and the filter here. Okay, so what I'll do is, there's a lot of different kinds of filter, but what I've been using recently, and maybe that's more connecting to the brand, is kind of like the understyle futuristic. So for example, FT1. So I think this really helps accentuate. For example, I think the way they do contrast is better here, bring out the details. So for example, if I use FT2, you can also adjust the amount of filter you would like to use. So maybe something along these lines is good. So I think before and after, maybe you can just take a look. I think the base of the render is pretty good already, so you don't have to do overall too much Photoshop. Sometimes I do, but I think it's maybe better if you can find the right workflow to get a good render and be able to do Photoshop less, post-production less, because you'll save time. So this is the result. So you see like previously there's less detail. With this, you can get more details, more highlights, and get sort of like a direction of the light coming in. And I think that will make a more attractive render. But also it depends like on the mood you wanna create as well. So it really depends on what sort of image you are trying to achieve. And it's good to have something in mind, maybe. Yeah, I think with this, more or less, it should be the end of the end of like what I'll be like demonstrating, more or less. But let me answer some of the questions that you guys have. Okay, Gabriel, sorry, Alex, I'll show you quickly how to do that a little bit. Did I make the script, C+ script? No, I didn't make the script. Like someone help me. So could you explain like what you mean by final mesh to KeyShot, Gabriel? Yeah, I think Blender is great for rendering as well. So I think the principle applies, may not be the setting that applies. Sorry to Alex. The setting might not apply to exactly the same, but I think I guess the overall lighting and trying to create the right mood and getting the details of the shoe is probably universal. So I think that is maybe what you could take from it. Okay. Let me show okay, Alex, let me show you real quick how I model. Okay. Alex, let me show you how I model that quickly. So usually I click the last. So like, you mean like from this blue color to this purple, right? So what I would usually do is, of course, I will have to decide a stack height or like the midsole height. So for example, I want something like that. What I usually do is actually take the last sub D and mainly just extend outwards. So this way I can maintain the consistency of the last. But of course keep a duplicate of this so you can use it. But basically it's not that complicated. More like oh. Yeah, usually what I'll do is just send something like that, and you're already starting to get the shape and let me see some tools. What I'll do is go try to make this bit wider. So usually from the front view, you'll see you'll see like a triangle shape from the front, like here and here at the edge. As a the reason for that is that it helps with the stability of the shoe. So it's good to have a wider base. Right. So with this, you're already starting to get the shape. So you can already almost use this as it is. Of course, you might wanna tweak it more to suit your design. But this is like the gist of it. Yeah. So Alex, I hope this kind of explains what you are looking for. You meant the upper and the grasshopper. Oh, okay. You mean this? Oh, this is easy. This is easy. It's pretty much just trimming from this. And I kind of like blended a surface here. So basically it's just, creating a curve, something like that. And trimming it, something like that, and trimming it. Yeah, it's just basically trimming. And you get almost the same thing. But of course with this, I created a separate piece that blended these together. I created a separate piece here on top of it, and I blended just to make this come out a little bit so that it's more comfortable to wear. But you might not necessarily need to have that. Yeah. Sorry. So I hope that answers your question. Sorry, the final mesh, what do you mean by the final mesh? The mesh of which part? Could you let me know? Jonathan, are you using the drag command on the surfaces? Sorry, I don't really know what a drag command is. Drag. Yeah, I'm not using the drag command, Jonathan. I'm curious if you try using LiDAR scanner on your foot to make this space shape more accurate. No, I didn't use a LiDAR scanner on my foot because I'm making it for like it's based on a shoe last. So like the shoe last is like the standard for you. Of course you can tweak them, but I didn't use my foot because there's sort of, I mean, we are designing for almost like a average size. So if it's just my foot, it's probably only maybe more suitable for me and a certain group of people. Maybe like, for example, you have wide feet, then maybe it's like more for wider feet. So I just use a last that's generally suitable for most people. Yeah, so like the standard last, you can get them online. I think I saw some on Etsy where you can buy and you buy and you can download them. Yeah, you can definitely find them, or you can find physical ones that you can scan if you want. You can do a LiDAR scan with a physical last and bring that into like geometry.
Hey Ping, is this the end or you have more to do?
Yeah, I think this is pretty much the end. I'm just answering the whatever
okay.
additional questions
No
that
worries.
they have. Yeah. It's all good. Yeah. So yeah, if you guys no problem, Jonathan. If you guys have any questions, let me know. If not, this is pretty much the end of the webinar. I hope you guys enjoy. If you have like questions, you can still reach out to me. If you do have any questions, and I'll see how I can answer them.
Well, thank you so much for your time and all
Mhm.
the wonderful things
problem.
you showed. I'm sure everyone enjoyed it. And thank
Mhm.
you everyone for attending, especially the ones that
Yeah.
stayed all the way through.
Thank you.
We
Yeah.
really appreciate it. And yeah, of course, afterwards, when the video is done processing, you'll get an email to check the recording.
Mhm.
So thank you, everyone. I have my camera's not working, so I can't wave goodbye, but I'll just say goodbye and
Thank you all again.
I can wave goodbye.
Bye.
Goodbye,
See you.
everyone. Thanks so much for like joining the webinar. I had fun sharing with you guys. Hope you guys had fun too.
Thanks. See you.
See ya.